Okay.
Please welcome our next speaker, Lucas Lasota, and his talk about when our routers are not free.
Hello, everybody. Welcome to my presentation. I'm very, very happy to be here in Zagreb. This is my first time here. And first of all, I would like to thank DORS CLUC for this opportunity to talk about, router freedom. And yeah, thanks a lot. Also, thanks a lot for the technical team to solve all these issues quickly. For those who are seeing us on the internet and you are visually impaired, I'm a bald and beard guy, and we are in a room full of nice people. And yes, the talk today is when our routers are not free, the challenges for open and neutral internet. Just quickly about myself, I'm Lucas Lasota. I have a legal background, and I also work as a lecturer at the law faculty of the Humboldt University in Berlin. So, but I've been to the free software world already for some years, and I really like it, and especially when it is combined with hardware. So the agenda for today is that I would like to offer you a quick brainstorming about why routers are important, and then we go about router freedom. And I'm not coming with empty hands. I also come some very interesting information. If you want to change the landscape of the internet, with if you wanted to, you have a nice idea. I will also present some funding opportunities for developing software and hardware together. So let's start with our thought experiment. Who has internet at home here? Yeah, okay, cool. Who has a router at home? Yeah, okay, yeah, the vast majority. Okay, cool, so I think the experiment will work. Imagine you are moving to a new apartment, right? So you're leaving your apartment, moving to a new one, okay? When you arrive in this new apartment, you know, and you wanted to have the electricity running, the water running, and then you contacted the electricity provider, and you bring from your old apartment your freezer, your television, and microwave and toaster, and now the electricity provider says to you, unfortunately, it's not compatible with our line. But I said, yeah, but I'm living in the same city here in Zagreb, so I live next to the train station. I moved here to a region close to Algebra, so it's the same city, everything is the same. But the provider said, no, it's not compatible. You cannot use your freezer, your microwave, your toaster. And you're baffled, right? You say, why? Why is that? And then comes the building administrator of the building and say something even worse. And say, look, unfortunately, your car, your bike, it's not compatible with our garage. And you say, what? I cannot put my bicycle in the garage? Yeah, you cannot. So does it sound a little bit absurd? Yes, it sounds. But interestingly enough, when it comes to routers, and this is exactly what is happening, right? So basically, internet service providers in Europe can deny interoperability with routers based on objective technological necessities. And this has been happening since 2015. And we at the Free Software Foundation Europe are working to basically eliminate this absurdity, right? But let's understand how we get here, right? So in 2015, in 2016, there was a very important piece of legislation. It's called the Open Internet Legislation, and it introduced the principle of net neutrality in Europe, right? And one of the principles of net neutrality is that the data flows in internet should be neutral. So basically, the internet service provider cannot, indiscriminatorily influence on the data. And one of the elements of net neutrality was that end users, basically we, consumers, we can choose the equipment that we want in order to connect to the internet. If we wanted to use the smartphone to connect, we can. If we wanted to use routers, and we can just go to a tech store and buy whatever router we want. And here's what's written in Article 3 of the law. End users shall have the right to access and distribute information and content, use and provide application services. And here, use terminal equipment of their choice. Terminal equipment is the equipment that we use to connect to the internet, right? Irrespective of the end users provided, location, origin, destination information, blah, 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 via the internet access provider. So basically, your ISP, the law says very clearly, cannot impose you their equipment. Well, so thank you very much for your attention. This ends my presentation here because we are good in Europe. No, it's not like that. If it was that simple, we would, there is some elements here that makes this law not that automatically or self-executable. And in order to make this, there's a whole set of regulations and bylaws and directives that implement on national jurisdictions in order to make that European level law applicable. So in 2018, there was a reform in the telecom law. And this reform imposed another set of rules, right? Saying, okay, fine, end users should have the right to use their own equipment, their routers, but there are some technological necessities, some aspects that internet services providers can limit this right. So basically, ISPs can say, look, if one of these necessities occur, we can limit your right. And what are the necessities? Basically, interoperability between the public network and the router, simplicity of the operation, network security, and data protection. So if the operator if the telecom operator tells the national regulator saying, look, for the sake of simplicity of operation, we wanted to limit end users' ability to buy their own routers and to use their own routers, right? For network security, and security has been the scapegoat for network operators, and we have been seeing all around in Austria, in Germany, in Portugal, in Spain, everybody's talking, yeah, for the sake of the security of the network, we need to restrict this right. However, I think commercial interests still play a very important role, right? But, you know, perhaps someone will ask, why are you spending so much time, why are you spending so much resources in fighting for router freedom, right? Why this is so important? So let's put like this way. Basically, if you are accessing the internet from your home, your whole internet traffic is traveling through your router, right? And during the pandemic, it became very clear that not only your communication for private purpose, but also your entirely professional communication is going through routers. So basically, we heard in the talks before, if we are trapped into lock-ins, into walled gardens from the routers manufacturers, basically we are completely dependent on our access to the internet as well. So with router freedom, we have the opportunity, for example, to think to buy the routers we wanted to run, open a free software distribution into our own equipment. You can customize, we can use the type of equipment that we want. And of course, this also has a very positive impact on security because basically we have been, I'll show in a minute, surveying people all around Europe, and they say, yeah, my router provided by LSP is not secure. There is no updates provided. So basically, there's a whole strings of vulnerability, and I'm not able to do anything about it, right? So basically, with router freedom, we have control. We are empowered to control our equipment that we use to connect to the internet, and this is really, really important. But I think everybody agrees on this, right? And so what we have been doing, we have been monitoring the whole situation in Europe, and we want to make sure that this law is really a reality, is applicable in the EU. And I'm very happy to show you that there are a lot of countries that have passed local laws saying, okay, end users, consumers can use their own routers. So if you go to this link, you can find the information about your country, right? And I would like to thank Zvonimir here for providing information about Croatia. because sometimes it's hard for us to monitor this law for every country. So volunteers contributing to our work send us reporting, oh, this is what is happening in our country, helps us tremendously in order to keep this map updated. Right. So basically, since we are here in Zagreb, I can give some insights of it, and please feel free also to contribute if I say something that's not completely correct. So basically, the Croatian telecom regulatory agents said that end users are free to use their own equipment. But there is an exception. The exception are fiber networks. So if you have fiber at home, you cannot use your own equipment, right? At least the optical terminal equipment is property from to the internet service provider, right? So you can use your own route as bridge mode, but the optical element is still property of the ISP. This is not what is happening in other countries. For an example, in the Netherlands, in Belgium, in Finland, they have passed local laws saying end users can choose not only the router, but also the modem. And when it's about fiber networks, you can also use your own optical terminal equipment, or use just a plug in your router that accepts the fiber cable, right? But yeah, you can check on your country what's the situation over there. And we want, 4 years ago, I'm sorry, 4 years ago in 2020, I started contacting network regulatory agencies. So HACOM here in Croatia, Bundesnetzagentur in Germany, and I wanted to ask them if end users have problems with their own routers and what the authorities are doing to solve these problems. And unfortunately, I found a very, depressing situation, because the regulators, they were not properly monitoring the situation, right? Sometimes people wrote them and they didn't do anything. Some regulators did something and provided very long, reports. That was really cool, but was absolutely not the rule in the EU. So we decided to do it by ourselves. And in the last 3 years, we have been conducting a systematic survey in order to collect experience from consumers, from the community, in order to understand what are their problems. And here is the report. If you wanted to check the report, it has 20 pages long. It's very cool to see what are the problems. But there is still some issues here. First, it's really cool that almost everybody agrees that router freedom is very important for open internet. So people just said, yeah, I agree that router freedom is important for freedom of choice, privacy and data protection, interoperability, fair competition, and security. But unfortunately, when we check how many people are in fact using their own routers, the numbers are very low. Actually, if we see a fiber connection, people using their own routers, just 4% of the people who answered the survey, right? With DSL, it's a little bit better. So 27% of the people using DSL uses their own router. But with fiber, it's really, really low. So, of course, there's a lot of work to do. And if we want to run, free software on our internet access devices, router freedom is very important for that. Well, this is an overview about router freedom. And as I said, I didn't come with empty hands just to show some problems. But if you want to help us to develop new technologies, and later today, we will learn about some dudes that are developing their own routers. So that's really cool. But if you have some ideas and you are searching for funds to help you in developing further in this idea, the Free Software Foundation of Europe is part of a consortium called the Next Generation Internet. It's funded by the European Commission, and we help projects to to develop solutions that will improve the internet. And it can be hardware, it can be software. And if you want to get some funding for your project, please feel free to apply. There are several rounds of funding, right? The next deadline is in the 1st of June, but these funds are recurrent, so new deadlines are open. So in this link, you can find all the requisites to find about this funding. The threshold is low, so we are working with LONet in order to provide this. LONet is a non-for-profit organization in the Netherlands. So they really work hard to make this process not too bureaucratic. So if you have an idea, please check the website. The fund is from 5K to 50K euro, you know, and we have funded already more than 400 projects already. So and it goes from, as I said, hardware, network technologies, and software development, VPN, and all this type of stuff. If you have an idea, please feel free to check the website and to see what are the themes and what are the thematic areas that we have been funding. So for example, here are some of the examples. We have the Zero Core, Commons Fund, Social Fund, research and higher education technological funds, and regional funds. So all of that, it's available for us to develop. And of course, this is strictly for free software and open hardware, so the result of your project should be published under a free software license. So this is really cool to foster free software in Europe as well, okay? So basically, this is the end of my presentation, and I would like to know more about you. Do you use your own router? And thank you very much for your attention. So questions? Yes, there we have.
Would you consider it using your own router if you have the modem from your ISP? For example, in Romania, it's all about the fiber, or you get copper to your house and then still use a modem, and then use your own router, because mostly the ISPs in Romania use PPPoE, so you can just get a username and password from the ISP and you can connect your own router. Mm-hmm. Would you consider that free? Using your own router, basically?
Right.
From your criteria?
Okay, that's a good question. Let me do this in Romania. So do you have the opportunity there to also use the optical terminal equipment?
I haven't checked, frankly, because
right.
Using your own optical is a pretty power user.
Right, yeah. So first, if you have the opportunity already to use your own router by bridge mode, you know, this is already a great achievement, I would say. Just to exemplify more or less what happens in Croatia, yes, you can do so, but the terminal equipment, the optical terminal, it still belongs to the ISP. So we consider like yellow. So like point B, it's halfway of full router freedom. If we have the opportunity to use even the terminal equipment or to connect directly the fiber equipment to our own router, then we would say that is full router freedom. But you can reach out to me, and then you can just write an email, and then we can update the chart in Romania.
Sure.
Thanks a lot. Yes. So, right.
I mean, there is a difference whether they're obliged to do it or they allow it to be done. That's basically, let's say, a legal distinction here. Whether there's like a local bylaw which says, if a user says, I want to bring my own router and connect it instead of so there's maybe the distinction here. So practically it's possible, but maybe it's legally not fully defined.
Yeah, this is not a question, but rather a response. So the problem with GPON in particular, so with optic fiber that most of us know, is that the one port is shared by one port on the ISP side of things on their switch is shared between 16 or even up to 128
Yes.
people.
Yeah.
So by forcing you to use their own, at least the lasers, they kind of make it safer for everybody, because one bad actor with one bad laser could take the whole branch down. So there is some reasoning to why they enforce at least the optical part of their modems.
Yeah. Thank you for this comment. This has been raised out in our survey, and this has been the main argument for the optical, for the ISPs that's working with fiber in Germany. So basically, in Germany, they submitted a petition to the regulator saying we wanted to cancel router freedom because of that, So you can affect a whole round of local users if we have one bad actor. But then we asked them to say, is there, some metrics in the last years in Europe of this type of disruptions of the network? And they were not able to demonstrate that. So I think the risk of having people disrupting the whole section, it's very low, because, well, you can, this is not a telecom rule, but you can be processed by civil, even criminal law, if you want to disrupt that. That's why, we asked them for some numbers, and they could not provide that. But yes.
But it happens. I mean, you own all the modems, and then simply one modem goes crazy, and it brings down the whole branch. And if you're a telecom and you own all those 128 modems, then you're in control to try to fix it. So this happens internally to the telecoms because some modem just goes crazy, Or there is a problem if somebody plugs in point-to-point Ethernet into a GPON. It can bring down also the branch. So these are things that do happen actually to the telecoms in the operations. For example, in Croatia, there was a migration, people who were on AMIS from point-to-point to GPON, and this migration had to be done very carefully, because if you end up being plugged in with the point-to-point Ethernet in a GPON, you'll just bring down the whole branch again.
Right.
So the technical issue exists. I mean, you can turn it around and say, what is actually the plug? Is the plug fiber plug on the wall or the Ethernet plug in the modem? So you can say, in this optical terminal. So that's how you can basically try to, the telecoms could also reframe it, saying,
yes,
I'm not giving you the fiber, but I'm giving you the Ethernet port on the
on the wall,
on the
yeah.
ONT,
Yeah.
on the ONT.
Yeah, and perhaps that would be the relevant to know in Romania if that's the case. Yeah.
Is it smart to use NG-ROC to reroute traffic to bypass your router to internal device? If you need
I'm not familiar with that. If someone knows this, perhaps can help me here, because
NG-ROC is a small piece of software that can reroute basically traffic behind any firewall.
Okay.
You must have PC to run it and to reroute it to some IP,
Okay.
internal IP address.
Right. I think sorry, I'm not familiar as that, so I cannot answer that. Right. One more question? Yeah? No? All right. So thank you very much again, and thank you the organizers for allowing us to be here.
Hello. Please welcome the next presenter, Tomasz Zaman. The title of his presentation, I Was Disappointed with Modern Routers.
Okay, so welcome everybody for attending my talk. My name is Tomasz Zaman. I'm a software/hardware developer from Slovenia. And today I'd like to talk to all of you about whether another router is really necessary. Yes, thank you. But thank you. But first, before we get to the router part, I need to give you some context. Around 2009, my sons were born, twins, and me and my wife, we moved to a really remote location of Slovenia, and I needed to, earn some money to provide for the growing family. So I basically needed to learn something on the web. So what I chose to, or was forced to by my first customer was Typo 3. Do you know Typo 3? Anybody does? Okay, Typo 3 is a very popular CMS in Germany, and it has a very, very steep learning curve. Actually, I would argue it's a straight line. However, and I should say also, I did the certificate for Typo 3, which back in the day, for those who remember, we had to manually drive to Vienna, sit there in front of a committee, and do the certificate. It was an uphill battle. And because I live, you see basically here where I live, so that's in the middle of nowhere, right on the border. So if you cross the border, you fall down into the abyss. No, I'm just joking, that's Hungary there. I was trying to put bread on the table by working on ELANs. Do you remember? Anybody remembers what ELANs is? Nobody. Okay, so it's now called Upwork. Upwork, you probably know. It's an online outsourcing service where you can hire anybody for pretty much anything. And there I met my then co-founder. His name is Per, and he's a Danish guy. And I was doing Typo 3 work for him because I, as a person from the Balkans, were relatively cheap from his standpoint. I was still making good money. He was making good money, and everything was hunky-dory. However, we still had some issues with this ELANS portal that we met each other on. Namely, from his perspective, he had to sift through hundreds of people, many of them from developing countries that would work for like a couple of euros per hour, and I would have to basically compete with all those people in order to get work, right? So at some point I said to Per, because we were working for a couple of years together, I said, listen, I can make something better than ELANS at the time. I can build a portal, but what I suck at is legal stuff and accounting and all that, paperology. Would you join me in this journey? So he said yes, and together we formed Codable. It's a Danish, or it was a Danish startup. It is a Danish company, quite successful, I might say. So yearly revenues now are in the millions yearly, and the company has 20 employees. And at the time when we were starting out, we needed to focus on a niche because we knew that if we did it in a general manner, we knew there's too much competition, and we're more likely to fail that way. So what we did was focus on WordPress. And as I said, to this day, the company has, 40,000 or so clients worldwide, so it's a successful one. And actually during, the event that we all know and don't love, which is the pandemic, I had a bit more time, so to speak, to reflect or do some introspection. And what I discovered is that after roughly 10 years, I wasn't enjoying working at the company anymore. Even though it was our baby, so to speak, it was fully grown up, and I felt I gave it everything that I had to give it, right? So I brought that up to Per, and he saw that, he knew that, he felt that. So we came to an agreement that I will leave the company, so I left the company in 2022. And then I, with some extra money that I was not used to, with plenty of time, I figured, okay, what's my next kind of business, so to speak? And the next business I wanted to build was one of my hobbies, and that is keyboards. I love keyboards. Well, I hate most of keyboards because they're cheap pieces of plastic that fall apart after a couple of months. So I actually did develop and invest quite significant sum of money of developing my own keyboard, which I have it with me, and you can see it later after the talk if you want to try it out. It's a fully functional keyboard. However, I discovered that the competition is very stiff and the margins are very slim, and the type of keyboard I wanted to make, or I did make, was very sturdy, powerful, durable. I wanted to make a keyboard I will leave to my grandchildren, basically. And as you can imagine, building I succeeded, don't get me wrong, but building a keyboard like that takes a lot of money. Like producing a keyboard, we're talking 300, 400 euros, just the production costs of a keyboard like this. So there's no way, and most people don't care about that kind of level of quality. So basically that business idea turned into a hobby. I still sell a couple every now and then. I still build them for my friends, for my business partners, but it turned more into a hobby, so to speak. So obviously, the next item on my hobbies, hopefully turning into the businesses, was networking. I love networking, always have. Like, I have a rack in my basement, which is probably unhealthy, both for, mentally and power bill. But, you guys understand, right? So I was like, okay, what can we do? And I was like, okay, I have this router that I built myself because I couldn't find the perfect router, so to speak. So I bought this super micro mini ITX motherboard, but it came in an ugly enclosure, and I hate ugly enclosures, as you'll see during this talk. So I was like, okay, I'm gonna make a beautiful enclosure. And actually, I did make a beautiful enclosure. Can I play this? Oh, yeah, I can play this. So I made this enclosure just for fun, really, like in Fusion 3D. And I put this on Reddit, of all places. And Reddit kind of got crazy. Like, I went to sleep, and overnight there were like thousands of upvotes, which on Reddit is hard to achieve, and like hundreds of comments like, dude, where can I buy this? You have to make this commercially kind of available. I want this too, right? People were impressed, really. And yes, it is a clone of like Apple Mini, or what is it called? Like, I like that design, so I was like, let's make it look like that, right? And then the next step was that I actually anodized it and put this on Reddit too, just to kind of enforce/verify it. And everybody was again like, dude, I want this, right? So I was like, okay, I'm on to something here. But I didn't want to repeat the same mistake as I did with the keyboard, right? I didn't want to invest too much money into building a whole batch of this. So I was like, okay, I'm going to turn it around. I'm going to spend no money, well, almost no, because I had to pay for some prototyping, but that's cheap. So I was like, how can I do this and spend no money? And obviously do it the opposite to what I did with the keyboard, because with the keyboard, I just did it kind of, in a basement, telling nobody, until I spent thousands of euros and, spent a lot of time. So I was, okay, I'm going to share this journey on YouTube. So I opened the YouTube channel. I was like, okay, I'm going to be a YouTuber now, right? And that happened like about a year ago. And I really started sharing weekly updates, both on the router and some, my passion projects or just stuff I wanted to talk about on YouTube. And the channel actually picked up quite significantly, to the point that we've raised actually a significant sum of money from YouTube, or from people that found me on YouTube. In fact, for the router project, up to these days, and we're just closing all the deals as I speak, we raised $300,000 to develop this router. And of those $300,000, $225,000 came from people that found me because of my YouTube, and I didn't know before. So literally an ISP from a country that I won't disclose them yet, subscribe to my YouTube, you'll learn eventually. So they reached out and said, listen, I want to invest 100,000 British pounds. Oh, I gave up, yeah, anyway. So, and we already signed the deal and the money is already on our business bank account. So that's all because I chose to expose myself on YouTube. However, I knew I wasn't gonna do this alone. Like, it's hardware development is expensive, both in time and money, resources, stress, morale, everything. So I already knew a guy. This is my now co-founder, Aljaž Titorić. He lives in Eindhoven, and we'll see how that's relevant shortly. He already developed the PCB for my keyboard, so I knew how he works, and he knew how I work and think. So when I said, Aljaž, would you like to join me on this journey? He was just in between the jobs, and he was like, fuck yeah. Can I say fuck? Okay, thank you. So he joined the mission, the journey, and obviously I knew how he operates because this is the PCB we developed, and I wanted this PCB to be transparent, the solder mask, to see the copper below. Why is that important? Because in a couple of months' time, we're still working on documentation. We will be open sourcing the whole keyboard because, as I said, it's a failed business project, but it's a successful hobby one. So why not share what we learned with the community? So we're going to share all the step files for the keyboard itself, so for the frame, for everything, plus the PCB. And we just basically, because of the investment, we incorporated a company called Mono Technologies Incorporated in Delaware. Don't judge. Foreign investors said, listen, we're not going to invest in Slovenia. It's, you know, a bureaucratic mess. That is the reason. Everybody's like, ooh, tax evasion, blah, blah. No. Try invest in Slovenia, you'll see what I mean. Anyway, so what is wrong with modern routers? Modern routers, first, they look like toys. Case in point. Molim? That's what? Yeah, but it's 1 gigabit fiber, and this is the one I got from my ISP, so it's modern enough, I guess. Second problem, they have horrible UX, both from visual, like from the outside, all the blinking lights, all the ports, everything. And third, they're missing advanced or even sometimes basic features. And I'll give a short story on this. I helped my friend the other day debug their Ubiquiti gateway, whatever it's called. And there's no logs. Like the PPPoE session could not be brought up for whatever reason. And there's like, where do I look it up? Why it's not, it's like, it's a beautiful device, horrible UX. I don't know why, and it's a basic feature. Just give me a bloody debug log. Anyway, we've been here before. So yeah, since we are on the topic of this router, I'll share a story as well. So I got my fiber in 2020 with this router, and the first thing I asked the technician while he was in my home, I said, listen, can you give me something better? And he was like, dude, this is something better. And I'm like, seriously, that's all you can do? And like, yeah, and can I get rid of it? No. But can you at least put it in bridge mode? Yes. But I was still bothered of having a device in my stack that I knew was there for no purpose because, well, let me go back actually. So this router actually comes with an SFP port behind it, and it comes with an SFP module, right? And I was like, okay, can I at least take the SFP module out of the router, put it in my switch or router? And they were like, no, you cannot. And this is very me on character. Like if somebody says it can't be done, it's like, you know, drug, like, okay, I'm gonna prove you wrong. And I did prove them wrong. It took me 3 months to discuss, 3 months because I was only able to tinker with this, you know, from the midnight onwards because the internet wasn't working. So the waifu and the kids were not happy with me. So it was a nightly venture, right? So what I discovered, it took me 3 months to see that when you plug in the SFP module into the router uploads the serial number onto the SFP module. That's why it didn't work if I tried to move it to my switch because it didn't have any serial number that my ISP uses in order to authenticate with the other side, so to speak. So I was like, okay, so I will take this, and there's no way for me to get into the SFP module, which runs like a tiny Linux or something. So what I did is I just intercepted those packets and I did what's called a replay attack, basically. So I would take those packets and just put them in a script on my own router, and then just run that script every time things got restarted or anything, and it was working without that router. And the whole details of the story are also on my YouTube channel, and in 4 months it got like 1 million views, so people really seem to like this kind of stories. Anyway, the first plan, obviously, when I decided I want to make my own router, was to manufacture the enclosures. But there is a problem with that. I mean, I know how to manufacture, design, and anodize everything when it comes to enclosures, easy. The problem is when you want to buy pre-made motherboards, turns out they are very expensive. Even from smaller companies, they would quote me, even you know, when you would order batches of thousands, they would quote me for 600, 700 euros for a single PCB. Now add to that my own costs of manufacturing an enclosure, and you come to a price of router like close to 1,000 euros. Nobody will pay for that, obviously. So I was like, okay, I guess the plan to manufacture enclosures isn't gonna, hold water. So we go to plan B. We'll develop our own router or our own PCB. And actually, naively, I thought that was super simple, super easy. Turns out it's not. We'll get there. But current state is that we're working on the schematics. So we already built the block diagram. So for our router, we decided, I'll go briefly over it. So we'll have two SFP plus ports, 10 gigabit ports. So it's, I'm also kind of, I guess I want to be a bit more green. So I want devices to be a bit more durable for like 10 to 15 years. And, 1 gigabit ports or 1 gigabit speeds have been invented in what, 1999? So we're talking 25 years. So if we put 10 gigabit ports on, we're going to go good for another 15, 20, 25 years, right? Then we're going to have 3 auxiliary RJ45s. It's going to be powered by an NXP processor, LS1046A. We chose it because of price performance and because it has general purpose A72 ARM cores. And it has what they call DPAA, so an optimized data path, so they can do firewalling on a hardware layer, so to speak. So this processor kind of ticked all the boxes for us. Apart from that, we're talking also about 16 gigs of RAM, 46 gigs of eMMC storage, everything built on. And the one thing I also need to mention is that it will be powered by OpenWRT. For my taste, OpenWRT still violates the one rule I hate about routers, and that is UX. I strongly believe it can be improved UX-wise, but that is a story for another day. So currently we're, current state, we're waiting for the development boards. Actually, I've just got on the mail that I have to put in, import the disposition, like import the stuff. Development boards are basically boards that are pre-made by the producer or the manufacturer or the developer of the CPU. You buy them and they have everything on it, so you can test thermal characteristics, throughput, firewalls, like firmware, everything, right? So these boards are very, very important for us. They're also very expensive. We're talking almost 2,000 euros for like one board, right? And we need to, just to give you a perspective when it comes to money, when it comes to hardware development. So one development board that you need, but one is not enough, but let's go with one, is 2,000 euros. Then you have to have a special debugger, which is basically a connection between your PC and the board. Costs 500, 600 euros. So we're on 2.6, let's say. Then if you want, then you need to pay for the license for the IDE, which is the integrated development environment, the software, and it costs either 3,000 or 5,000 euros. 5,000 euros being the one that lets you test memory, because memory is very sensitive, very complicated to route on a PCB. So we're talking like for one person, initial investment, if you want to start with this shit, 10,000 euros, give or take, for one person. However, we decided, I can brag that we are well funded now, so we could afford this, so we ordered 2 licenses, 2 of each basically. We've already done with the schematics. Here I need to thank, I guess, my co-founder. He lives in Eindhoven. Why is that important? Eindhoven is the European Silicon Valley, meaning that you find engineers for everything on every step, basically. It's like 200, Eindhoven in Netherlands is home to like 200,000 engineers for everything. So it's super easy to hire people, and we actually did hire somebody to help us part-time to route the RAM, because they have experience with high-speed digital interfaces, because high-speed digital interfaces are very costly to develop and very demanding. So how do you route traces to, like 1 gigabit is easy, give or take. 10 gigabit is super complex. We're talking you have to calculate nanoseconds with traces on boards. That's how complex it is. But we're 60% there. We're also working, we hired an agency that will help us do the visual design. And why am I saying port UX? For example, right now, we're thinking of where to put PCB vertically so that when you plug it in, whether it's a difference whether you have to lift the device to get your finger for the tab to plug it and unplug it, right? Do we decide that you have to lift it, or do we decide that there needs to be enough space? So questions like, it's a trivial question. It sounds dumb, but somebody has to think about this question. So how people will interact with both the physical and the digital aspect of the device, right? So yeah, we hired a company, one of the leading Slovenian companies for industrial design, and we're super happy with their progress. Unfortunately, can't share anything yet. Subscribe to my YouTube channel when it's ready. It will not look like this. This was a teaser, I guess. This was the initial version. It'll look very different, much smaller, which I'm super happy with. And I'm looking forward to show you all when it's ready. We expect it'll be ready sometimes in Q4 2024, September, October, hoping, as I said. YouTube channel will give all the information when we're ready. However, all this money, all this effort will not allow us to put the device on the shelves yet. $300,000 is enough to bring the prototype out, and that's it. What is not included in that kind of money is certification. Like CE certification can cost, you know, if a device doesn't have Wi-Fi, so you have a feeling, we're talking about 100,000 euros to certify an electronic device. If it has Wi-Fi, we're talking 350,000 plus. So that's kind of ballparks we're looking at, right? And plus, if we want to invest, or when we want to mass produce the device, we need enough funding to produce, I don't know, 1,000 of them. Because if you buy 50 chips, whichever chip, like a CPU, it costs 70 euros. If you buy 1,000 of them, it costs 50. If you buy 10,000, it costs 30. So those kind of ranges are also important. So you need to be able to market this thing. I need to be able to market this thing successfully, because it'll take, we're talking at least probably $1 million to get it on the shelves. And yeah, that all ties into my YouTube channel. So YouTube channel is both my marketing, my education, my sharing with the community, all in one. Thank you. Questions?
Thank you for the amazing presentation, amazing project that is really, really, really inspiring. Can you go back there? How did you manage to talk with the ISP in order to remove the ISP plugin to put in the router again? How that happened?
They said this. So I said, can I get rid of it? They said no. And then I felt like I knew nothing of GPON at the time, so I was just looking at the forums, reading how all this fits together, how the standards look like, and I was basically, you know, trying out. I know some, you know, basics about hardware or firmware development. So what I did also I bought like SFP modules. I Googled what the chip or the SoC on my SFP module was that was provided by the ISP, and I bought like 6 or 7 SFP modules from, you know, questionable vendors. And then I soldered on the how do you call it, the leads to my UART debuggers so I could get in and see what's going on and how they work, and it's a big mess and it's horrible. So that's how I learned, and then I found, luckily, on fs.com, I found a module that actually allowed me out of the box changing the serial number. So this module has been a godsend. I've been using it for 3 years now, and it persists. So it writes it to Flash when you update the serial, and it works. And I got no help from ISP, and I said, can you give me at least multicast servers for IPTV? No. The only pleasant or positive person was the VoIP support. He gave me everything. He was the only person that gave me the username, password, VoIP servers, because my wife's parents, they need the landline still, so we needed a VoIP phone, and he was the only person helpful, said, listen, here you go, your password, your everything. The rest, it can't be done. And I was like, can you give me level 2 support, like the higher ups? Yes. Hey, can I do this? No. So this was but I should say, my ISP otherwise, apart from this forcing me to use their gear, is a good one. I had no, I have gigabit, no problems, very stable, very high quality ISP. With this, they would be perfect.
Thank you for a wonderful, very inspiring talk. So
thank you.
I come from a background where I used a lot of D-Link and ASUS and some other routers, and the UI there is just beyond comprehensible. Like it's insane. So the moment I installed OpenWRT, it was such a breeze of fresh air. And now your comment made me actually very curious. Could you name one or two the biggest gripes you have with the OpenWRT UI? Like why is it not?
Does your mom understand it?
No.
That's the problem. No,
but she also doesn't have to.
Yes, she does, because her TV calls home with what's happening in the network. She doesn't know that. So we could educate. So we could use the interface to educate. How many people know what VLANs are? It's basics. 1 out of 100 maybe. I mean, not here, people here excluded. So the problem is the interface is not bad in itself when you know what you're doing. If you're new to this stuff and you log in, you'll go, oh, right? That's the problem. Like here, I have to comment, on the other hand, Ubiquiti. Their UI is at least prettier, right? But it also makes, it doesn't make perfect sense, but it makes more sense. It's easier to see how things are connected together, so to speak, right?
Okay.
Catch me later.
Okay.
I have a lot of
Sure.
to talk about.
Well, the guy from Telecom Sweden says this is the good stuff. And actually it is, because the other modems that telcos are using are far worse than AVM. They're like far, far worse.
Yes.
Both in the hardware quality, and especially in the software quality and consistency, it's a mess. So
yeah,
this is actually when telecoms really try to do something with the modems. Then at the end they usually go with the AVM.
Yeah.
Those who don't, they just give you.
Yeah. No, it's stable. I didn't like how it looks in my rack.
Hey, great talk.
Thank you.
One question, did you try testing speeds with this new router that you had? Did you get like 10 gigabit over PPPoE or something like that? Is there something like that doable?
I don't know yet. We'll try. So the plan is to try it. Slovenia is a tiny country, so when you're a YouTuber, everybody knows you, even if you have a couple of thousand subscribers, right? So I already am talking to some ISPs, and some have even offered me, obviously in return for some content, to lend me their gear so I can test this. And it will come, but I don't have the boards yet. But that is one of the things I'd like to try out. Plus the NXP, so the company that builds the processor, also have this, they're called ASKs, which we're talking to them about. So it's a special firmware that's specifically router optimized, right? So so the majority of things, PPPoE included, is hardware, done in hardware, and leaves CPU, like the general cores, out of it. There is a drawback. The license costs $60,000 yearly. So we'll see. No decisions yet. Thank you.
when you decided to use NXP Freescale Motorola chips, did you sign non-disclosure agreements for the integrated development environment? And the case, is it Flex ATX, ETX, which is form factor actually?
Yeah, so yes, I had to sign NDAs, but not to use the chips. I can use so for most manufacturers that we're using, the biggest ones were Micron, NXP, and Marvell, which we're not using. I had to sign in order to see the data sheets, the core data. I mean the how do you call the extensive data sheets, right? And their timelines, but I didn't have to sign the NDAs to buying them. The form factor in the new PCB will be nano ATX, so 12 by 12 centimeters. Okay, thank you very much.
Do you tend to make an access point as well, like have a Wi-Fi on it as well, or just
Step two. Step two, maybe within a year or two. Yeah, I want, I super want to. It all depends on the next round of investment, because I don't have to raise it. We will raise it, and if we get there, then
the next? Sorry, I have so many things now to ask. So, but this thing you made with hacking your own thing, I'm not thinking. So I have a similar station in Switzerland. They're sold, and they have their own routers they give you, and the fiber.
Please welcome the next presenter, Jakov Petrina-Trnski. He will be talking about production line automation.
Thank you. Thank you very much. Hi, everyone. Well, thank you for joining us. It's great to be here again. I was in 2022, I think, so it was 2 years ago. And I'm happy to see some familiar faces and some new ones, right? Anyway, to get started, basically, from the title, it's a bit hard to understand what's going on. So we have production line automation and hardware testing, but the most important concept is obviously that we want to test some hardware, right? So this is what my job will be to basically explain what we did in this project and how have we tested it, right? Okay, so to give a bit of background information, my name is Jakov Petrina. I work for a company called Sartura. My colleagues, Alan and Bruno, yesterday have given a bit of background about the kind of work we do. So we are basically an embedded Linux company. We specialize in low-level stuff like kernel development and bootloader development as well. But obviously, we also have some embedded Linux expertise for application development and firmware integration, right? And this is what we strive to do. Also, together with this, we basically highly focus on open source, and we have invested quite a lot. So basically, the amount of work that we do, we usually focus on open source. For example, when we contribute patches upstream, we want them to be kind of like we want them merged upstream so that the community can maintain them better, right? And together with this, we also work to develop some custom features that our customers need on open source solutions, right? Okay, so this is just a sneak peek of the kind of technologies that we are into. So for this particular project, we're talking about OpenWRT, Linux, and U-Boot, and obviously robot framework. However, we are also engaged in quite a lot of different ventures. For example, the most important one being Dent recently, which is a Linux Foundation project, where we try to open up network hardware, for example, switches and so on. Yeah. So, like on the presentation, on the title, there is production line, but how come? I mean, production line in Croatia. But this is why we teamed up with Soldered. So basically, at Sartura, we don't really do hardware. So we teamed up with Soldered, which is a company in Osijek, Croatia, and they have various brands. But the one that we are mostly concerned about is the Soldered manufacturing, where they have provided us with electronics manufacturing service for the boards that we have decided to design, right? So yeah, we had an opportunity to actually go on site and visit the guys at Soldered in Osijek, and it was quite a exhilarating experience to see all the production line machines and so on. So kudos to the team. Okay, so let me tell you exactly what we are talking about. This is basically a case study. So we have hardware design and actual hardware production. Basically, in the beginning, we wanted to make a hardware appliance, which is a networking device. And on the market, there were not quite a lot of devices which fit our needs, right? Either because they were too expensive or because they did not have the features that we required, right? So we started to float the idea to design our own hardware in-house. And basically, once a long-term client expressed interest in this, we decided to go ahead with it and try to do it on our own. So basically, the main idea was to use an expansion board to basically use a platform which already exists out there, and simply to make a board out of this base, right? And obviously, we wanted to cram as much as we want on this form factor, so we went ahead with an SAP port, expansion cards, and Ethernet ports as well. So this is what you're talking about. We're talking about a system on module called Habanero. This is from 8 devices. It's basically a Qualcomm IPQ chip, which is it's fairly good, very well supported. It's currently Wi-Fi 5, which is a bit older, but when we started this project, it was the best at the time, right? And it had the best support. This is what we are after. Basically, our idea was to extend this SOM with additional components, basically memory. We decided to go ahead with around 500 megabytes of RAM, and we decided to have around 200 megs of NAND storage, right? Together with this, on the networking side, we have 4 1 gig ports, and we have 1 SAP port. I think it should be, yeah, 1 gig. Obviously, we have all kinds of other peripherals, like mini PCIe, which is quite good. We have USB 3. We have a USIM slot, which might be used by a customer if they so desire, and we can power the board using either PoE or another kind of input, right? So yeah, it's quite interesting device, and we designed it in-house. This is the hardware render. As you can see, we have the 4 ports over there. There's the SAP port. Basically, there's a lot of components which are not visible because they're on the bottom side. For example, here we have a connector for the external memory, which can hold, I think, around 64 gigs of storage. So quite a lot. So yeah, we have the standard plug-in jack and so on. And this is how it looks after production. So the boards are pretty well manufactured, and after manufacturing, obviously, we needed to test them, right? This is what we had to do, right? Okay, so how to test these boards? So you have a hardware. You can do, like, I don't know, by hand. You can try it out, all of the Ethernet ports. You can try the SAP port, see if it works. You can try Wi-Fi. You can try memory, everything. But obviously, you don't want to do it by hand for each board. And we're talking about more than 500 boards for production. So we wanted to set up a test methodology. And for this, we had some requirements, right? It has to be automated. You cannot do it by hand. Or semi-automated, depends on which stuff you need to test. For example, there's also LEDs, which need to be tested as well, right? Obviously, this test system has to be reliable. One other thing is it has to be cheap, so you cannot invest quite a lot into some kind of additional testing equipment, at least for this project, right? And it should catch production issues. So because we decided to go with testing batches, right? So I don't know, we would make like, I mean, the guys at Solder would make like 1 or 2, and we would catch, I don't know, something that has to change or have to fix it. And we wanted to catch all of these before sending it to the client or making them more than enough, right? And one other requirement was that given that some of these boards would go to customers, we have to make them production ready, right? We have to set them up so that the customer can use it out of the box, right? And obviously, as part of this methodology, we need to decide what to test. So basically, we're testing up power up, booting, we're testing network, very important. We have to test peripherals, all of them, like NAND, I2C, mini PCIe that it works, and so on. And together with this, I mean, you can test memory all kinds of ways, right? But we need to confirm how to test them. We could, for example, confirm for network that packets are sent on an interface, but there's no need for performance testing, at least for us, right? And for all of the peripherals, we decided to go ahead with enumeration only. We didn't go with either performance or any kind of other tests, right? And obviously, together with this, we have some manual tests to do, like LEDs, and we needed to test PoE functionality as well, both in and out, even though for out, the customer decided not to use it, so we didn't have to test that. Okay, so how to implement these kind of tests? So we had to design how to set up the hardware for testing. This is by itself some work that we had to do. We had to develop OpenWRT-based firmware, test firmware for the boards. We decided to go ahead with both a tester, and testee, or device under test board, which needs to be covered. And we had to develop all of this, which kind of, would it be a script or a more generic framework? Should it be like, I don't know, like bash scripting, or should it be something more fully fledged? It took a lot of thought, right? And obviously we had to write all of the documentation and so on. Not just to use it, but also to extend it by need. And we actually did that. So we basically designed a test setup which would use the board itself to test itself, right? So we confirmed one of the boards that was working perfectly, and then we actually took it and considered it to be a tester device. And then we would make this device a self-contained unit, which would not connect to anything else. It would not, for example, need internet or something like that. And it would test another board, right? And this is basically our test lab. So we have one board, the tester, and we have one board being tested, or as we call it, testee, or device under test, right? Obviously, this device under test, we need to change it, right? We need to power it. I mean, generally, we are okay with having to do this manually, but given that these two boards are self-contained unit, you can have, for example, 20 test labs, right? You can have 20 test instances, right? And obviously, we need to develop the test firmware and software and additional hardware components like connecting PCIe cards and so on, right? Okay, so this is how it looks. We have a workstation, which obviously is either PC or laptop, which connects to a single tester board. It connects via serial connection, and this tester board is connected directly with all of the Ethernet ports to the testee board, device under test. And obviously, device under test has all of the peripherals that we need to consider. So it has USB device connected, it has power, it has serial connection is obviously needed. We need a mini PCIe card, we have SFPs, we have NAND, obviously already soldered on, and so on, right? And this is how we consider this to be a hardware setup, right? So the test process generally goes as follows. So we set up the hardware as shown on the picture. We prepare the tester device itself. I mean, generally, you do this only once, right? You simply flash the firmware on it, establish console access as a developer, and then you can go and put a testee device, right? And then once you connect the device, you simply execute the testing framework, and that's it, basically. So unfortunately, there are some complexities with this. So first of all, how should you power cycle the testee device, right? Because at some points in the testing flow, you have to, for example, flash a bootloader. Then you have to reset the device, or for example, you have to flash new firmware or stuff like that, right? So we decided to go with, I don't know, like smart power plugs, but it depends on which requirement is. You could do it manually. Why not? I mean, it's not that much effort. General serial communication, well, usually there's some issues with this. If you use, it can be sometimes unreliable. So we are dealing with both non-interactive stuff. For example, when we have boot up sequence, you have, for example, U-boot spewing out data, then you need to parse it. You need to, for example, enter U-boot shell, which, for example, you need to press, like, I don't know, any kind of key or some sequence of keys. or something like that, right? And then once you enter the U-boot shell, you actually have an interactive shell, which you need to deal with as well. So we need to reliably parse everything. Also, we need to ensure that the device under test is consistent. So for example, suppose that you start up the device under test and it does not have the appropriate firmware. This is a problem, right? You need to confirm that it's set up properly. There are some additional test complexities, at least for us. We wanted to get some data out of the device under test. This is a special case to handle. For example, Mac is usually burned into memory on each of the device in production, so we need to extract it in order to put a label onto the device. And we had a very important requirement to update the bootloader, and this is usually very, very, like, I don't know, like, very problematic. You could burn it out, and then you have to save the board using memory flasher, right? And another test complexity is that we are not automating checking for LEDs or whether PoE works. I mean, generally you could do it, but given that we wanted to have more cheaper solution, we decided to have the operator use a manual step and simply confirm once the test is up and running, right? And basically, we took a look at what was available, and we decided to go with robot framework. I'm not sure if anyone has heard of this robot framework. It's usually in the context of web development. It can, I think, drive like opening up websites, pulling data from it, and stuff like that. It's quite interesting. It's open source. It's a more generic framework. It has like a lot of additional libraries. And one interesting aspect is that tests for when written in robot framework are more close to human language syntax that it is to scripts, right? So it is a good option here. And this is how the stack for testing looks. So we use robot framework as base for all of the driver of the test system. We have, for example, serial library, which is a wrapper over Python serial. We have console dialogues, which is basically a custom wrapper over another Python library, which is questionary. It basically allows the user to have prompts, whether yes or no, right? Obviously, the firmware is important, so we had to develop custom firmware for based on OpenWRT, so we had to enable some kernel options. We had to enable additional packages for this and dependencies of these packages as well. Additionally, we had to develop a custom packages to handle all this robot framework stuff. And we added everything together as GitLab CI/CD just to have release pipelines and build artifacts in place. So this is how an example robot framework test case looks like. So we have three main parts. We have the settings part where we define which libraries the testing will use. Then we define some variables and define a test case. So here we have a test case which basically the test case is called my single robot test. It creates a new file. It writes into the new file this good text, which is basically hello world, and then gets it out from the file and confirms that it is equal, right? Pretty standard. But when we deal with an automated test case on the device, we had to use serial port communication. This is very stripped down version, basically. So, for example, we had to verify which U-boot we are currently running, because once we flash over the new U-boot, then we don't really, we have to handle this point, right? So here we confirm the U-boot version, which is from the factory, right? From the Habanero module that was delivered to before putting onto the board, expansion board. And then, for example, here we wait and enter the U-boot shell, right? And all of these, for example, enter U-boot shell. This is a command by its own, which is defined in additional, for example, common resource file, right? And this is how it looks for a manual test case. Here, for example, we confirm that the LED is operational. Basically, we write to the registers of the device, we execute this as a prompt command on the, I think, U-boot. I'm not sure if it's Linux. And then we can execute a manual step, and the operator will confirm that the LEDs are powered on. And this is how the CLI interface looks like. So basically, we start the testing framework. We have 01 pretest, which is a robot, the whole suite, right? At the start, we confirm that the operator has power cycled the device, and then they have to just press the key. And once that's done, then we can go ahead and execute all of the test cases. Here we, for example, verify the U-boot version. We wait and enter the U-boot shell. Once we're in, we can extract information from the device. Here we had to, based on our customer demand, we had to get out the MAC address. And then once that's done, we can send it out as an HTTP request to some other resource. Here it's some default one. And this is usually, for example, for MAC labeling, right? You have to write down labels on the device, and you don't really want to do this manually. So you can just send it out to a printer and do it and be done with it, right? And obviously, once the printing has done, then we wait for the operator to confirm that they've placed the MAC label on the device. And that's pretty much how it works for the remaining stuff. And this is how the boards look connected together. It's quite a mess, right? Yeah, basically, one interesting stuff, we had to use an USB hub because, for example, on the tester, so this is the tester, this has to handle, it has to handle serial output from the tested the device, the DOT. It has to handle, for example, USB storage because we have a lot of firmware that we need to flash onto the DOT. And we also had a requirement for Ethernet, so used a simple Ethernet like USB adapter because we had additional requirement to send this MAC address to a local LAN or something like that. So because all of the 4 ports Ethernet are busy, right? And this is how it looks, and it works. Okay, so basically what our takeaways for this, it's possible to have reliable communication with an embedded device. We used Python for this, like PySerial, but obviously we can do it with additional open source software. This has been achieved with exclusively open source stuff. It's fairly modular. You can basically override the defaults in this system. You can add pretty much easily additional test cases, and you have a detailed command line output, you have manual confirmation, and you have verbose logging if needed. And with all of this venture, there were some interesting insights. So for example, during all of this, the unfortunate global chip shortage occurred, and these are events which have to be taken into account, and this slowed down the production of these stuff. We had to wait quite a few months to get everything on track. There were also hardware production quirks. For example, we tried out to have the device. There was an issue with the connections between the modules themselves on the board. This is referred to here as problems with castellation of the edges, and obviously device certification, which takes a lot of time and is, as previous speaker mentioned, quite expensive, right? So yeah, that's pretty much it. Thank you for your attention. Are there any questions? Seems that no. Anyway, thank you very much.
Thank you for enjoying the presentations. You can take a lunch break until 1:40. when Debra Hustic will be talking about art and technology. Please welcome the next presenter, Deborah Hustic, who will be doing an art and technology talking.
Thank you. Let me sing a song, and no, I'm just joking. Thank you very much for coming to the talk. As some of you know, and some of you maybe don't know, so I'm here on the behalf of Radiona, which is actually a citizens lab. We started 14 years ago as first 2 years as a media lab. Oh, I'm sorry. Yeah, as a media lab, and then we switched to the Makeover format because it gained us much more interesting people. And then after 2 years, last year we decided to be, as the changes are coming, and we decided that maybe Citizens Lab is actually more appropriate, and all of these things with the maker spaces were just actually kind of a little bit going down, which is not a reason, because you simply want to make something, and these are the diverse formats. But it's up, whatever we actually see ourselves as a kind of a community and a collective of people with the grassroots in the hackerspaces. So what I want to talk now, because a couple of years ago I talked about actually Radiona, which is on DORS, which was streamed. So I was very cautious not to make the same PowerPoint presentation or something like that. But this is more now the emphasis of this talk is more about this symbiosis that we have on creativity and technology, because we are a collective of like also super geeky people, and also like creatives and people who are from the arts and humanities. And we like this diversity that we are actually for 14 years combining, sometimes uncombinable, yeah? So what I wanted to start with is that we actually are developing STEAM practices, so science, technology, actually, engineering and mathematics were always present, but it was also the creativity, because the lab was founded in combination by people who are into arts, design, creative things, DIY enthusiasts, jointly with people who were engineers, programmers, and super geeky people based on the open source. The lab was always more oriented to open source technology and hardware, so we were not so much usually there was this with the hackerspaces, it was always like the situation that you would have people like around, you know, terminal, not communicating so much. You wouldn't see a lot of women there, you know, it's kind of this a stereotype. So basically I can say from the beginning we were breaking up these stereotypes of how these spaces should look, what they are like, and things like that. What you see on the photo is something I will talk at the end a little bit. This is the geodesic dome. Is the dome that we have built last year at the Velebit mountain in Baška Oštarije, where we are running the Electric Wonderland Maker Camp this year for the 6th year. It's an international project where we, for 7 days, gather people, bring some people from abroad, and we hack things, we have workshops, diverse kind of stuff, you know, from electronics, synth building, FPGA, bioart, foraging in the nature. The idea is one year, maybe this year, to finally do programs which are more, you know, about our physical activities and, you know, getting us to hiking, and because we have such a full and crowded program. And a lot of people from abroad also come. We had guests and people visiting us from United States, from Asia, from Israel, from Switzerland, from Germany, just name it. This was last week. Is this streamed? Oh, okay. So I'm just checking what I can say or not. No, what I want to say, this was last week. This is American artist Adam Zaretsky. He is a biohacker. He's a MIT student, and actually somebody who studied also there, but from the visual arts. And he's been doing biohacking for the last 20 years, really. And what we were experimenting at this workshop was, of course, DNA extraction, which is not something like this is the This is something experiment that you can do at home. Yeah, it's not such a complex. But he brought nanoparticles of Titan, which was putting the workshop on the next level because we had to go out because you have to do, if anyone reads the nanoparticles of Titan, you can just like, drop that very soon. And also like the other participant brought the nanoparticles of gold, that she had spared somewhere. And this is the moment when we were experimenting with fruits, with our body parts, and we were blending and mixing. One was contaminated block, with our part of our skin, the hair and everything, and blending. I washed the blender very carefully after that. And the other one was also like fruits, meat, bugs, if I may say, but we were not so harming a lot, just like the regular things we do. But it's like, it was very interesting to see how we can actually experiment with, and with something else, and these were the elements of spermidine, that is now the hot thing, in beauty industry. It's been used, which is from, if you can check, it is something apparently very I'm drinking part of this for my memory enhancement, yeah, but there is been for autophagia use now and things like that, and some of the elements from the pills that are intended for arthritis. So this is kind of a cutting edge, let's say, the bioart and biohacking, but still there was no harming. So that's one of the elements. Why I'm making this, it's one of the things that I want to, it doesn't have to be so controversial. It doesn't have to be in that sense. This is one element, but it's not necessarily the combination. I wanted to put it as an example because bioart is usually considered, it's usually something like this, either controversial or it's either put in the box of something that our weirdos are doing, or it's a biological experiment. What I find for years pretty much inspiring is one of the workshops, I think it was 2009 or 2010, from Umea, the School of Design in Sweden, but it was also one of the workshops from these two authors was made in UMAS in Split, which is a art academy. What the two authors, and it's one of the first kind of examples of interactive arts, citizens participation, and design, of course, speculative design, and hacking and playing around with the first versions of Arduino, was basically that what they did, they wanted to raise awareness, the designers wanted to raise awareness to citizens, to how their environment is functioning and how the insects are basically seeing and hearing. So they made basically a helmet, and something like, it's not a glove, but kind of a device that you can put on your hands, and then you go in the park, and of course there are several iterations of it, that when you put this, and when you are kind of small in the park, having this on yourself, you are basically having these simulations and stimuli the same as the ant is seeing what he's been seeing and what he's been sensing, the touching. Yeah, so we have to talk about that also in order for people to understand now, like in 2024, when we talk a lot about the climate changes, the environment and things like that, you see that something that was almost like 14 years and more made, that it's still so relevant. It's very relevant in the way, and in the way how we communicate technology, how we make complex knowledge that your professions are dealing on every day, how basically we are going to present people what we are doing. And isn't this a very cool thing to do? Even the healthcare industry and even all of these open source, we also cover it in our exhibition as open source medicine. Things are going on, but it's very nice to use playfulness and a combination of creativity and electronics into when you present and when you're dealing with a certain topic from the society. One of the things is Aerocen that was also like inspiring us. We have this international project of these camps that we are doing, and one of the partner was a lot into Irosin. I don't know if some of you has experience in Croatia with these flying objects. Yeah, there was a couple of years ago in schools, in this network of teachers were doing and launching, you know, Raspberry Pi with a balloon. You know, it's also like something that you have to be very careful when you launch. It has to be connected with astronautical societies, because you cannot just launch, it's similar to drone, you cannot just launch really high, you know, up to the stratosphere an object. These are objects that are intended to be you know, up, you know. This was designed by Thomas Saraceno. It's a Czech artist, an architect and designer who actually decided that he will deal with the flying objects. And he still researches, you know, the ancient ways, how people like, for instance, in Croatia, Faust Vrančić, how Leonardo da Vinci and a lot of others, inventors in the history, were doing the flying objects, but also like going into the contemporary in the science and how to use scientific, let's say, laws and rules in order to design and develop flying objects. So Aerosen is intended to fly, and you can build up this, it's very super light balloon that doesn't have any kind of electricity. You just have to fill it in. It is such a light material that you just actually, you take it in your hand, and then you take the air in, and it should be flying up. But it looks very cool on the photos, sure. And of course, we were so inspired at Radiona. Like, you have this was by our partners in Finland, this photo, like, can you find kind of this kind of in Croatia? It looks like, you know, like a photo from a Burning Man or something. So we decided, let's go, because there is a Tetra, an open source on the website of the Aerosen, which is a network, and you can join if you want, whoever wants. We decided to build our own Tetra from plastic bags, you know, and we actually did it 3 years ago for the first electric wonderland that we had at the Camp Velebit, in Camp Velebit in the Velebit mountain. And we said, like, okay, let's do it. We can do it. And we bought the material, we stick it. We brought the guy, Frano, who was sewing everything. Everything was really done super, like, well, this was the first, our third camp and our first attempt to actually put the balloon up. So we bought, it's good that you have this machine for blowing the leaves, because you have to put inside, you have to put the hot air, you know, but it just has a hole all the time, and it's all the time it's supposed to be. We were running all of the half of the Lika, we were running around with this. It was really, we have on Flickr a gallery, it would take forever. So you see this, for instance, this was also, it looks like it was the size almost like a 1.5 car, like a SUV, you know. And still, but it was like, we were so proud to catch this photo, because it was like this, so kind of, that's the maximum. And we were like, what happened here, you know? And so we decided at the end of the year, kind of, we won't be frustrated. We had, as we are doing exhibitions, couple of them per year, we decided that this Aerosen should have a central space in Technical Museum. And that was it. But it was even challenged. How are we going to manage this balloon? Will go down, you know, and then we found the mechanism and everything, the adapter, like with the remote, every couple of hours, then taking care that nothing happens, that it explodes out of air, that, you know, it was challenging in this sense. But what I want to say, we started 2 years ago when I asked people why we didn't, how is that happening, that this was that we couldn't put it in the air. Then people told me, like, it was too heavy. The duct tape was too heavy. And for going in the air like a meter, I had to contact the National Agency for Self-Flying Objects, for being a pilot of a self-flying object. It was a kind of, Zadar airport is so close. So what is going to happen if something it is fly away because we are not aware? Then we were thinking like, okay, we have to raise awareness about this because on every party, people will want to make from a trash bin plastics will make flying object, which you objectively can make because it's possible, you know. And so then we got information that it was too heavy, and then 2 years ago we basically made our own aerosol from a super thin plastic bags that are not allowed anymore. And for 2 years now we are waiting because I need the candidate in my lab who wants to wake up some Saturday at 6 a.m. so we can get it out that nobody sees it, you know, somewhere in Zagreb, because otherwise we need to ask. Yeah, let's do it. We can do it. If anyone who wants, yeah, please, at the end, because it's kind of, we have to be very careful about that because you cannot just put such a flying object up. If winds happens, it's really like, I was thinking about all the birds, planes, and things like that. So that's a story about playing around with open source, let's say, design, art, and technology. The other thing that within this is a work of our lab member Mario, who's been an expert in repairing, in this part of Europe, in repairing the cash machines, yeah? And what he does is basically, he's been, of course, the guy he pretty much influenced, because that was his childhood, with retro gaming. So what he does now is that he recycles, with no intention to talk about the green things. He recycles part from these cash machines that are disposable. So basically, and he builds up retro gaming devices and consoles, you know, arcade consoles, which are made either on FPGA technology or with the pits that you will see, or with also like the technology that was of his youth, yeah? And we like that exhibiting at the exhibitions for a reason that we like, I mean, it's not just exhibiting the production that we have in the lab, but the twist with these kind of things that he does is that people are actually playing on this, but they're also like not aware that they're in front of the cash machine, yeah? And that this what is the currency? The question is, what is the currency here? Is it the game? Is it the process? What is this? Because they don't, if we don't say them, they actually don't know that they are playing on a cash machine. The other thing that you see in the back was also like a couple of us were, and Goran is here too, who we were working on these boxes. We got the digital eyes. You will see later on this photo from the Technical Museum, digital eyes, which are of course closing as if there is no action in front of the boxes. What has been interesting, we were inspired on this of creating, let's say, digital objects and a classical one as a piece, as something that has been a sculpture. And we like putting them in galleries, in libraries and things like that. When people don't know that something is next to them, and then all of a sudden when they move, it moves, it opens the eyes. And it's the question, of course, is like, is it this connotation, what do you think actually? Is this a box with eyes? Or is it that somebody is in the box? Yeah, so that you have these funny moments with interacting it. And of course, some of these were based on peer sensor or proximity sensor or ultrasonic, some of these installations, because it was Corona. And we were also thinking, when all the galleries and museums were completely like shut down, nothing was touchable, and we were thinking like, okay, then we should go and rethink how we interact with objects, why should all the museums and all of a sudden, like when you have these super science museums and people are really investing a lot into these interaction devices, what shall we do now if the touch is not allowed? Then we see how much this interaction is actually pretty much important. And of course, talking about this is also like the user experience design, if some of you is from this area, because it's how do we communicate the ideas behind it, why it should be just a geeky thing. We like having older people in the exhibitions. We like people who are expecting, you know, paintings on the walls, who are expecting photographs on the walls, and they come in front of interactive devices, which are not here just for the beauty, but they are here to tell something. Yeah. And this is another also lights based on Pitt's Boulder Dash, of course, the small edition. I think it's there. This Mario did everything. It was even the 3D parts were 3D printed on a 3D printer that we made the first generation. Igor, who made this, yeah, this is his installation. This is his device that he made for the. We made 1 year exhibition that was about drawing machines. So we were interested in a lot of ways how we can draw, how these machines can draw, and he made, of course, as being also like super technically skilled, he was thinking about why don't we make something like that. It's a software that draws, yeah. And of course, you see on the screen how the software is drawing in itself. Yeah, so that people who are not used to this kind of knowledge, who are not used to this kind of technology, can actually see this, you know, as a process. You know how the machine is playing with itself, yeah, and it's drawing. It's being I wouldn't say a painter, but as someone who is making a machine is making a random creative process in itself. And when you print, you get this. Of course, you get this printed, you know, and you can take, and it's uploaded also online. So this was about the concept of a drawing machine. It doesn't have to be just a pencil who's been like with motors similar to any kind of mechatronics device and doing something. This is for a couple of years ago. This is, let's say, a lawnmower that our also lab member Ivica did. We had an exhibition about sonology, the sound, and all of we built a lot of sound devices and synthesizers, but he was playing with the lawnmower. So, and he put a lot of stuff there, the sound and things, but participants at the exhibition were with the remote, could drive to the hall, the museum, could drive the lawnmower, the device. What was funny, and it has also twist for us, was like when we were closing the exhibition, the director of the museum came and she was taking video of the robot going out, and she said, this is the future happening now. It's the artifact from the museum is already on its own leaving the museum. So when we will get to this kind of like that stuff that we exhibit, the artifacts are going home on their own. So it's like the moment that you get this kind of, when you're aware of this. And you see 2 years later, this is at the Ljubljana Maker Faire. This was the same robot. It got really like it's a car. And it got quite a big attention as it is. I don't know where it is now, probably in the garage of his home, but it's super sweet how really like in 2 years this lawnmower, something that has a function, and it was even cleaning the floor in the museum, is getting now into complete different direction. And it was super cool, you know, to see people, you know, playing around and see that they can drive it, you know, by not killing someone in your area. One of the things is also, this is like Igor's installation, that was, and Damir's installation in the Technical Museum when we had, I think, gaming playground. We had 42 exhibitions in 14 years, so a lot. Is that it's a hacked skate also, like with some electronics, and basically you actually are driving this skate, you know, on this. You have everything from the beamer, from the projector happening in front of you. That's also like the thing that sometimes we like to do when we go when we work on installation and installations, and the technology is how to make, because we all sit so much, you know, people are, you know, having even the spine problems. We always kind of sit there. So what we can do, you know, to actually use this installation to move more. So we like to do this. We like to make them playable and things like that. This is also one thing that we were playing around, this year. We made an exhibition about the pixel art in a library, the story of pixels. So we were thinking, they have a children's department there, and it's amazing. And then we decided, okay, let's buy some super cheap Tamagotchis, yeah? And let's put them in a kind of green environment, kind of their own ecosystem, and let's leave it in the library so the children have to take care about the Tamagotchis in the library. Because we also it's something like it had lots of people, grown-ups, people came with their children and they told us kind of, wow, that's my childhood. Like, come on, how is this possible? But we were just thinking about this, how every year we discuss here, how people are taking animals, and then when it's time for holidays, yeah, they leave them. They're somewhere left behind. So there is obviously a necessity again to raise this awareness with younger generations about, taking care about some kind of entity, yeah, and then about the animal. So that was and it was funny how in this library, this is from Pula, the exhibition that we had in Pula, but in Zagreb they were really taking care about that. I think only one Tamagotchi was kind of not taken care of. I don't want to be like. So this is in addition to the fact that it is also interesting to use this technology in this playfulness and interactive way that it moves us, that it has that we have some kind of action and interaction and some kind of loop to ourselves. We were also reflecting in the past to the scientists who were stopped from, or they were in doing their own, like Galileo Galilei, like Nicola Copernic, like of course Alan Turing. You can check on Radiona's YouTube. We have the whole actually exhibition, how we set up the history of it, because Alan Turing was fundamental not just for computing, but also for biology and for biomimicry. So it's interesting to check because you can actually see it very easily. And Igor was making the Turing's machine. I think at that time it was 2016. It was a very interesting year in Croatia, and it was very brave, I think, to do it. This was a series of free exhibitions, but I remember that I think there was only maybe one Turing machine that we could, from the open source and DIY communities, that we could find online. There was later, afterwards, after 2016, that it started everywhere. This is also Damir's work, Infinity. This is the Infinity from the I think Gaming Playground 2 or something, where people can stand up and kind of being like, you have these infinity boxes that you have it down, and you look up, you get a little bit dizzy and things like that. So this is one of the moments that we had at the Technical Museum with these objects of connotations, with these boxes, is that we had one child coming for 1 hour. And he was all around, he was 3 years old, it's up, so we had the whole gallery of him interacting, because the eyes are also on the other side. So these are actually 6 pairs of eyes, and it was so sweet because he wanted to take the smaller one home after this 1 hour. But it was very, very nice how we see how actually we have this human touch when we deal with technology, especially with the children. And this is let's say, a public space, a space with no intimacy, a space where you are actually exposed, and to see how the younger generation and the youngest are reacting to technology. One of the things is, of course, this playfulness. This is from one of the newest lab members, Alexander, who is making, also like to make this kind of gaming stuff based on, let's say, I would say pixel LID, and we had one classic, Igor's classic. What is the Croatian word for letva? A plank? Yeah, a plank. So we had these gaming devices with the plank, you know, where you play in with an LED fighting in between. So he also made his own version, which is a very it looks like from Finland, from Eurovision, you know, guitar or something like that. You know, it has this heavy metal thing. But it's interesting to see because we put people into this situation. They really come and play, and what is different. What is here different is they get out of their comfort zones, you know. We like to have this combination between art, design, and technology in order to show people that they can touch devices. Whenever you go to museums and galleries, visitors are not allowed to touch, yeah? And what we like to do is basically show them, yes, you can do it. If it breaks, doesn't matter. We will repair it. Yeah, we have people to repair it. But it's about, you know, having this feeling that it's not like something that you have to have a distance. This is the FPGA, where also like the small visitor, this is Goran's installation, where he was playing around with this, with his own impression on the screen. Can you tell us something about this? No? Okay, he will tell you later. But it's kind of the thing that really is captivating, that you put very complex stuff in front of them, and it's very nice to see the playfulness and the process of it. This is what we did last year. So this is kind of, I have to say that it's one of the moments when we built the geodesic dome, we were talking about what is the next thing, you know, because we built ourselves in the mountain a lab, but also like what is the challenges when you run a space, when you do stuff, you kind of have this, you know, what you are going to do next, what is next, so what is kind of a passion that you have, and then we were thinking like, as organizations, so what is next actually, you know? We don't want to buy real estate, we don't want to go, we don't want to have our own museum or something like that, you know? We just like, it's okay to do stuff that you can give something to community. So Geodesic Dome was the idea for this was that at the Velebit, where we are now with the camp for the last 4 years, is that still there is not enough infrastructure for us to have like a lab that where you can work for 24 hours. So then we said, okay, let's find people who will, I will be in short finished. Let's find people who can actually build something like that or run together with us, run a workshop for 7 days. So this was built in 7 days. That's a very concrete thing. This is something that will last. This is our most expensive masterclass we ever had and workshop. This will last about 20 to 30 years. This is a concrete, let's say, I wouldn't say house, but something that can be used and something that will not be blown away by the first wind, especially somewhere where it's an alpine climb, especially during winter. It has 43 square meters. It's been high 44.5 meters, and the isolation is absolutely great for also like for doing performances. The wooden parts are so strong that dancers on silk can use it, you know, and you know that it has to be super safe. They can use it very easily. It has all the infrastructure now. It's been it has from Lexan the same shape windows, you know, so it's usable during the summer. It's very chill, very nice, because summers on the mountain can also be hot, yeah, during the day, but during the night and when it's cold, it's also, you know, keeping the warm, because the walls are really, really thick. And what I want to say is that it's something that we are very proud of it. And after this, we have to rethink about what we will be doing. What I want to say about the mountain thing, and I want to invite you, even if you want to come, check electricwonderland.eu, 22nd to 28th of July. So we are for 7 days in the mountain. This is installation with a laser on the mountain. You know, with the lasers down is the lake, and it's something that we made especially for it was the two artists from Austria, and they're internationally well known, and one from Taiwan. They were making, you know, we spent like an hour with the sound, but there was no electricity, so we have to take care to take the generator. Yeah, we take in a van, in the cars. We took some drinks with us, and they took equipment, and it was so big, you know, and it was a safe zone because, as you know, lasers are not kind of supposed to be used like this for the environment. So as you can see, we search always the new audiences, because basically we are not interested, you know, as we work, we are not interested in kind of, especially with the setup of the museums or galleries, we are interested in, let's say, ordinary people. Yeah, we want people, you know, that you see on the street that maybe are not visiting this kind of institutions. We want them. You know, this is something like how you can actually communicate science, how you communicate technology, how actually what we like to do is demystifying technology, so that people are not afraid of it, that people are not afraid of open some kind of device, that it's okay to repair, that it's okay to be, so that they don't think it's like something that they cannot approach or they cannot understand and comprehend. One of the stuff that we did was the Synthomere synthesizer, which was also, this was left from the previous presentation, but it's interesting that one of our kits also ended up the synthesizer at the Venice Biennale of Architecture. We never thought it's a very nice thing to do, you know, to finish, to end up in an exhibition of this kind. The other thing that I want to also just to address is what we do is, of course, that we are empowering women, you know, in the STEAM areas that we like to do, that we like to work in that sense with a lot of with the hardware. And here you can see with an aim and a goal to actually raise a generation of female workshop leaders. Yeah, that we have more women, you know, in technology, in the sense of as speakers, as someone who has been like being in a let's say more active role. Yeah, okay, I'm finished. I like it so much what you do. Yeah, I'm finished. Yeah. So this is the Fighting Robot workshop, and this is our space. It feels like home. This is for us very important, and that's. I want to Photoshop him for some of our meme. Because it's so sweet. Thank you very much. So, yeah.
masking, this place, and mirror. Changes. Yeah. And wow, it's not connecting, so I have it downloaded. Yeah, but it's not loading. It's trying to connect, so I have it on a PDF. I don't know how to put it into.
It's PDF. What PDF?
Yeah, I had it in a PDF because this is not loading.
Open the PDF. Maybe in some in the menu.
Have it like in the slideshow or anything.
Yeah. Present a slideshow. Literally, present a slideshow. Hello.
Yeah. Okay.
Hello, let's welcome Alexander Aldebra and his presentation, The Beauty of Hardware Translation.
Thanks. Okay, so hello everyone. As he said, my name is Alex, and I'll be talking about a 6502 emulator that I wrote some months ago. Before that, a little bit about me. My name is Alex. I'm a college student. I'm studying computer engineering at Spain. And I'm also a part-time infrastructure developer. And I've been coding since I have memory, basically. And the main goal of this project was to learn about dynamic recompilation. And so I figured that to get the basics of the process, I would try to emulate an older system that was not as complex. And also the advantage of the 6502 is that it was a very popular architecture in the past, and it was used by a lot of computers and a lot of consoles and everything, like the Apple I and II, Commodore 64, the NES, SNES, a lot of things used that architecture. So the very basics of the 6502 is that it's an 8-bit CPU. So most of its registers are 8 bits. It has 6 registers, and it can address up to 64 kilobytes of memory because its address space is 16 bits and it's addressed with little endian values, and I/O is memory mapped. So those are some of the basics. Yeah, so the registers are actually quite simple. We have an accumulator, which is used to store values of arithmetic operations, logic operations, loads and stores. Most of the operations that you would do in a 6502, you would interact either directly with memory or through the accumulator. Then we have the X and Y registers, which can also do some arithmetic, but are mainly used for indexing to memory. Then we have the stack pointer, which is also an 8-bit register, but the stack of the 6502 goes from hex 100 to hex 1FF. And so basically this means that whenever the value of the stack pointer is 0, it will access and write values to hex 100, and whenever it's 255, it will access hex 1FF. Then we have the program counter, which is the only 16-bit register of the 6502, and it essentially just points to the next instruction to be fetched and executed. And also we have the status flag, we have the status register, which stores the flags of any resulting operations. And to talk a bit about the status flags, there's 7 of them, technically. We have the carry flag, which stores the carry or the borrow after an addition, subtraction, and also some logical operations. We have the zero flag, which, as the name implies, is set whenever the result of an operation leads to a value of 0. We have the interrupt disable, which disables some of the interrupts, most of them, but some aren't, you cannot disable. Then the decimal flag enables and disables operations in binary coded, which is an older system of doing arithmetic with computers. We have the break flag, which is only set when there's an interrupt which is caused by a break instruction, and it's a bit unusual to use, but it's there. We have the overflow flag, which is set whenever an operation leads to an overflow. And then we have the negative flag, which is set whenever a value leads to whenever an operation leads to a negative value. So those are some of the basics of the 6502. And so for this project, since it was my first project doing dynamic recompilation, I didn't want to write like a whole backend that wrote actual x86 assembly or ARM assembly, at least for this project. So I decided to use LLVM, basically because I already have done some projects with LLVM, so I know a bit how it works. It supports a lot of targets. It supports x86, it supports ARM, it supports RISC, like most platforms are supported. It comes with a just-in-time compiler as well, so I don't need to be allocating memory that is with an execution protection or anything. It's just handled by LLVM. And I chose to use LLVM 13 because I tried to compile newer versions and my computer would crash constantly, so I just stuck with LLVM 13, and that does the trick. Okay, so the basic, let's say, algorithm for translating 6502 code into, in this case, x86 code is to, well, you have the first instruction that you want to decode. It's in the program counter. So you fetch that instruction and increment the program counter. Then you translate that instruction into LLVM IR. And then depending if the instruction is an unconditional jump or not, if it's not, you just keep transforming the instructions below because we're not going anywhere. But if it is an unconditional jump, you tell LLVM that you're done writing LLVM IR, and you tell it to compile whatever it has, and then you run that code. And that translated code is written in a way that it's essentially on the host machine, it's a simple function with some inputs that outputs the next address that you want the program counter to have after the end of the execution. So after you have compiled that code, it runs it, it returns you the next address that you want to fetch and to keep executing, and you do the same all over again. So to have a basic idea of how this process works, we'll manually translate this simple 6502 assembly that doesn't actually do anything useful, but it has a couple of edge cases that are quite helpful. So the first instruction that we'll decode is the compare instruction. This essentially just affects 3 status flags. It affects the carry, the 0, and the negative with its comparisons. And since this is not an unconditional jump, it's not even a jump, we'll just keep decoding whatever instruction is below that. Okay, so next we have the branch if not equal instruction, which basically translates to LLVM IR to a conditional branch. If the value is 0, then it was equal, so we continue, but if it wasn't, then we early return from the function, and we return the address of the next we return the address of the next code block that we want to execute. But since this is not an unconditional jump, it's a conditional jump, if we don't hit this jump, we're still going to be executing the instructions below that. So depending on how you want to write it, you could say that even if it's a conditional jump, you want to end it here. But in this case, it could be useful to just keep translating the instructions below in case that we don't hit the jump. Okay, so after that, we have a simple increment instruction, which just adds 1 to the accumulator. That's basically it. And then we reach the skip label, but at this stage, we don't care because it's just something that we use to see. The next instruction is the STA. And for now, what we will do is to tell LLVM that don't worry about it. This number 3 is a pointer and right there. We will see later that's obviously not correct. But for now, this is what we'll do, and we'll fix it later. And then we reach the jump start. So this code block is essentially a loop, not a very useful one, but it is one. And this essentially just translates into a return to the address of 0, which is the start of the program. And since this is actually an unconditional jump, we'll tell LLVM that we're done translating code. This is all the code we have. Yeah, this is all the code we have for now. And then LLVM will translate the code into this x86 equivalent code. Actually, if you see, it's actually quite similar. It has a compare, jump if not equal, an increment, a move. It's quite similar. But this has some obvious issues. The first one is that we told LLVM that it could write to address 3 and just don't care about it, and that's obviously wrong. That would probably lead to a sec fault. So we need a way to tell LLVM that when we're reading and storing from an address, we're actually saying that we want the, let's just say, front end of the emulator to do something with that address that returns or stores a value. So for that, we'll just, well, in Rust, they're called traits, and most other languages, they're called interfaces. And we'll have these simple functions that will tell LLVM how to read and write from memory. So if we come back to the example that we had before, this essentially means that this store instruction, instead of being an actual store, it just turns into a function call to the write U8 function with the specified address of 3, the value of the accumulator at the time, and some extra unknown data that may be needed by the function. Okay. Oh yeah, and this basically results into this LLVM IR and this x86. And the thing that changed was basically this green box where it moves the values that it needs into its registers and calls the function. Okay, so the next big problem with this is that we don't actually have a mechanism right now to keep the state of an execution of a block to keep it. Right now, if we went back to the example before, every time that we jump back to start, we'd have the CPU in the same exact state every time we called it, and that wouldn't do anything. That would just be an infinite loop that would crash your computer. So we need a way to essentially every time we're about to exit a code block, before doing that, we need to store the current state of the emulator back into memory, and then we can exit. Okay, I will not bother with going through the step-by-step of doing that with the example because it's a bit tedious, but we can see essentially that every time we're about to exit from the function, if we have modified any of the registers, we store that into memory. As you can see here, before this return, we have a store. And before this return, we store the flags and the accumulator, because we did, in this case, in the case that we do not hit this jump, we are modifying the accumulator, so we need to store that changed value into memory. But if we do hit this jump, this doesn't change the accumulator, so we can skip that write to memory. Also, we are avoiding this way writing to memory every time we translate an instruction, because that would be actually quite slow and would generate a lot of code. If every time I need, for example, to increment the accumulator, I have to read from memory its value, increment it, and then write back. Instead, if I just have 2 consecutive increments, I can just read once the accumulator, increment that value, increment it again, and then we can store back to memory, and we save memory accesses. Okay, so this LLVM translates to this x86 code. If you don't know a lot of x86 assembly, don't worry about it. I just put it here so for the curious, but the exact way in which it's translated, it's not too relevant. If you're curious, you have down below there a link to Compiler Explorer with this code, and you can play around with it. And yeah, and that basically solves most of our problems. But this is a bit underwhelming because, yeah, it's cool. We have a working emulator for the 6502, and you can write any code you want in it. But we can't actually see anything for it. So I thought that it would be fun to put this emulator and write a very bad NES emulator on top of it, so we can actually see something on screen happen and have some fun. But before we do that, there is one thing that we're missing if we want to do that. Well, yeah, this is essentially, this is the actual NES architecture. We will not worry about the audio processing. Obviously, the lockout chip, it's not a thing I'm interested in emulating. And extra memory or extra requirements from the cartridges will not be actually handled. This is just a very simple NES emulator to see the project doing something. But before we can do that, we need a way to handle interrupts. Interrupts are the way that other components of a system tell the CPU that they need its attention, and they have something to tell it, and the CPU should stop whatever it's doing and handle that. But we currently don't have a mechanism to handle this. And the solution I came up with this project is it's not a very fast one, it's not a very good one, but it's a one that works. It's that it's after we have translated an instruction, we'll call this tick function. The NES interrupts are very, very tied with the amount of cycles that have passed on the CPU. So this is an easy. So every time we have executed an instruction, we'll call tick with the number of cycles that that instruction would have taken in an actual 6502, and that tick function internally will have a counter. So every n amount of cycles, it will emulate an interrupt of the picture processing unit or whatever it is that would actually have raised an interrupt. So yeah, as I was saying, this method has some benefits. It's simple, and it's quite accurate because you're actually doing what the CPU would do. Before each instruction, if there's an interrupt, you have to handle that. The drawback is that this makes code optimization harder because you're inserting like garbage code in front of everything, and it makes it more difficult for LLVM to optimize certain parts of the code, and it also increments the size of the code quite a lot, having a lot of calls in between every instruction. But it does work. And so this I'm going to show you the result. I had a video recorded, but my internet is not doing very well right now. So instead, we're going to do a live demo, which I'm quite scared of. So this is it. And basically, whenever this initializes, oh, it's compiling. This has a lot of also handling code to display things to the screen and everything, but we'll not worry about that right now because it's not the main focus of the presentation. Well, it's Rust code, so you can see why people say it's slow to compile. In the meantime, I'm gonna see if I think it's actually gonna be faster if I find the video, but just let it compile. Yeah, actually, I'm gonna cancel this because I think I found the video. Yeah, this is it. Okay, so yeah, so here we have the emulator running Pac-Man for the NES. And one interesting thing that we can see in this video is right after I start playing, you see these stops. Those stops are because the dynamic recompiler, the way that it's written in this project, whenever it finds an unseen before code, it will stop the execution, translate that code, and then execute it. This has the problem that if the program reaches at some point a lot of unseen code, that will happen. It would stop the program and it will be quite laggy. The solution to that would be that instead of blocking every time we find code that we haven't found before, we should send that compilation process to a new thread and tell it to translate the code. And for the meantime, that the executor doesn't have that compiled code, just interpret it and keep interpreting the code until we have the compiled version. That would get rid of those stops. We can see that happening again whenever the game actually starts. This is fast, then it stops. It's a bit slow, then it happens again. That slowdown after we have hit one of the yellow balls. But after that, we can see that it's running. It's running perfectly fine. So yeah, I'm not very good at Pac-Man, so I'm gonna die quite soon. So yeah, I think here, yeah. Okay, so that's that's essentially it. Let me go back to the presentation. Slideshow. Yeah, that's essentially it. If you have any questions, you can ask them here right now, or if you want to ask me later, I'll be here around for some time.
Hi. It's quite an impressive project, but is there any real reason why you chose Rust over the other languages, or you just wanted to?
I'm quite used to writing Rust. I use Rust for most of the things that I write, so it was a comfortable language for me to write it in. I thought I had it already compiled, and it should have been a bit faster because it should have had the libraries already precompiled, but that was not the case.
Any more questions? No, then thank you, Alex. Hello, let's welcome Igor Brkic. His presentation is on jellyfish open power profiles.
Thank you. Okay, so hi everyone. My name is Igor. I will present you a project I'm working on for the last 6 months or something like that. It's it will be, because it's still in the relatively early development stage. It will be an open hardware measurement device. It's quite niche for the certain kind of people, but let's start from the beginning. So who am I? I'm a software and hardware developer. I develop hardware, I program, I do that for fun and for business. I'm the guy who made these badges. And yeah, this URL Hyperglitch, that's my company, which offers like hardware development, prototyping, research, and similar. So why? What is this power profiling I'm talking about? So basically, when you're developing some device which needs to work on battery for a long time, in the modern times, the IoT devices, some sensors which take a coin cell battery and work for 5 years with that, you need a way to optimize the battery consumption, because those ultra low power devices, most of the time they are sleeping, they aren't doing anything, and then at some point they just wake up, maybe read some sensors, send up the data to some hub server or something, and then go to sleep again. So in that sleep state, while they're not doing anything, the current consumption is in the order of microamps. Microamps is like even less than a microamp. And during the time when they start sending the data, they wake up and start sending the data, and the consumption goes to a few dozen milliamps or even more. If you're using Wi-Fi, it's 100 milliamps case. So you need a way, and if you don't have a way to characterize that, because in that short time, if you miss some part of the consumption, you will not be able to estimate how long will the battery last. You will not be able to decide which battery do you need for a project to meet with certain specifications, and so I wrote it's 5 orders of magnitude, and it needs to be fast, because the modern processors are quite fast. They are sleeping, then just wake up really fast to do some things where the power consumption is going wild, like up or down, and then go to sleep again. So you need something fast to measure that current really fast, to get an idea of like which part of the code is causing which sort of current consumption, and how to optimize that. Also, many mobile devices have integrated batteries. So when you're developing that sort of device, you need to develop also a battery charger. But when you're in the lab, on the workbench, when you're testing it, you need a way to test that battery charger, that it works. Of course, you have a bunch of spare batteries with different levels of charge inside. So like take one battery, connect it, see if it charges, then take one almost empty battery, then take one almost full battery. But it takes time. It cannot be automated. For example, if you're doing many changes, you would like to somehow automate the process of testing a device. With manually connecting batteries, you cannot do that. Why I also, since like those are challenges which I wanted to take, I wanted a device that can do that. And why also shouldn't we have a general purpose power supply? Many labs have them, but when you're in the field, it would be nice to bring something with you, like yet another multi-tool device that can handle many cases. So, of course, things like this for measuring current, they already exist. I mean, for the simplest task, when the device is in sleep mode, or when it's consuming when the power consumption doesn't change, you can just take any sort of multimeter and measure it, and you'll get a perfectly good number. But for these things where the things change, there are devices that exist. There is usually called source measure unit, and like they're not main uses isn't for this. They're mostly used in laboratories for like characterizing some semiconductors in the production, and they can measure like nanoamperes or femtoamperes, like some really small leakage current, which most people don't need. But if you want to measure some high dynamic range, then you have something like this. And these things are really expensive. Like they start at 7K euros for this unit here, or some better ones which are like second hand, but they go up to a few 10,000-20,000 euros or more. So based on that, because most smaller, this is not affordable for general hobbyist or a smaller company, there are some other affordable solutions like commercial devices. When I started working with ultra-low power devices, I was looking for this, and these are the main ones. So there is Koitek OT ARC. ARC is the previous version, ACE is the new version. It costs, the previous version was 800 euros, this new is 1,500 euros. It can act as a power supply. This is not a dot, it should be power supply 0 to 25 volts. It can measure current up to from nanoamperes to 5 amps at a sampling rate of 50 kilohertz. It has battery simulation and profiling, which is really cool features. Next in line is Joule Scope, which is around 900 euros. It's just a measurement device, but it can measure at a faster rate. So, and these two, they are in the group of affordable devices, because compared to the previous SMUs, where you need 10,000 euros for a device, company which develops some devices which needs automated testing can, instead of that, buy 10 of these and test 10 things in parallel, which is good. And you usually do not need those extreme low ranges, where basically the main reason why these devices are so expensive is because of those extreme ranges, like measuring nanoamps or femtoamps, because everything that is not a problem in normal use at those levels becomes a huge problem. So, and there's another really interesting device. It's a Nordic Power Profiler Kit, PPK2, which costs only 90 euros. It's a small device. Yeah, all of these devices are connected to the computer, and they have some software which you can use to measure, to graph the consumption and similar. So, PPK2. It's really fun device, cheap, and has quite good characteristics. It has also some limitations. It only allows, it's a power supply which can give, put out 0 to 5 volts on the output. It's not from 0, it's 1 point something volts to 5 volts. It can measure up to 500 milliamps of current. It can also be used not as a power supply, but just as an instrument, like a pass-through device, similar to Joule Scope. It can measure up to 100,000 times per second. And it's a great value. I know about this, I just tested Joule Scope, but I have 3 of these PPK2s, and they're great for pretty much anything. But those limitations are quite limiting, because this means that you cannot use it to test a device which works from 3 AA batteries, which works from 4 AA batteries, which is 6 volts, because it's outside its voltage range. If you have a motor or some active thing inside the device, it will for a short time pull a bit higher current, and this is a limitation. And it also inside, even though it's 100 kilohertz sampling rate, it's not really bandwidth limited. So in some cases, you can get the measurements which aren't good, which look okay, but actually it's missing some peaks in certain cases, which happened to me. I was measuring a sleep current of some processor which had really short pulses at random times, which PPK2 was ignoring completely. So, sorry. So, with that, I said yeah, I should build. I should be able to build a better device. Why not? It can be hard, right? So funding. There is a this is a side note. There is a great foundation called NLNet. It's like can fund projects from using the NGI Zero and Trust. I don't know the legal thing behind, but it's a great concept where everything they can fund projects which are somehow contributing to the better future, open internet, decentralization, privacy, and all projects which relate to that, which are in the open source space. They can give some funding to them. It's in the category of low cost funding. It's like lower value grants. It's up to 50,000 euros. But it's really simple without bureaucracy. It's like they have open calls every 2 months. So if you have any project which you want to develop as an open hardware or open source software, you can just check out their open calls and apply. It's basically just a small, short plan. They will call you if you fit the bill, and it's really simple. So I applied my idea to this NLNet grant, and I got the fundings, which resulted in me actually starting working on my idea. So let's go there. So what I want. I don't talk this much usually, so my throat is. I want a device which can handle multiple cases. So basically, I want a programmable power supply, just to power some stuff from 0 to 15 volts output that will cover most of the things. 0 to 3 amps current because, like, yeah, the same. It will cover most of the things. It's programmable because I want to be able to control it from software to turn on, turn off, do anything. I want it also to be programmable load, which means it can, instead of giving the power to output, it can just consume a specific amount of current, like just act as a device which is using power. Why do I want that? Because I mentioned that I want to test battery chargers. I want it to behave like a battery which will pull power from some charger, and I can measure that power and see if my battery charger works. Or any sort of power supply. I mean, I can connect just a huge device or a light bulb or something like that, but having an electronic load is really useful in many cases. So, what I want, the main feature of this device, I want fast and precise current measurement. I want to be able to measure current going both directions, like when giving the power to the device and when the device is returning power to the measurement system. So I want to be able to measure from -3 amps to 3 amps, like 3 amps in both directions. I want to have a high bandwidth, like 100 kilohertz at least. So which should give me enough resolution to detect every short spikes in the current consumption. I want to be able to, I previously said I want to measure from microamps to amps. And because of some reasons which I will cover in the next slide or so, there are reasons that measurement range cannot be covered in just one measurement range. Like if you have a multimeter device, you need to switch between measuring milliamps, microamps, amps, and it's the same here. You need a way to automatically switch the measurement range depending on the current. And I want a low burden voltage, which means I don't want the measuring device to affect the functioning of the device after it, because if the measurement device is like causing some errors, glitching power or anything, then device which is being powered cannot be properly used, cannot function. And while we were at it, why not add a bunch of other things to it? Because we can do anything. So I want to be able to have flexible powering of it. So I want to have the USB power delivery support, so I can connect it just with one cable to my laptop, which supports power delivery, or use the power delivery charger, which can provide up to 20 volts at 3 amps. I also want to be able to connect any sort of DC source if I don't have the power delivery enabled host. It's a device which is controlled from the host, which can be either computer or a smartphone. I can connect to my smartphone, why not, when I'm in the field somewhere. It should have some simple web UI to be able to control all of these basic parameters, but it should also be integrated into EEZ Studio, which is an amazing software solution for controlling multiple measurement instruments. Similar, it's like a Jupyter notebook, for those who know what it is, but which also includes oscilloscope, multimeters, any sort of measurement device can be integrated into it, so you can pull the data, screenshots, and it's an amazing thing. So what else? I want it to be isolated from the host, so it doesn't have galvanic connection between my laptop and that. Not really needed in most cases, but sometimes when I'm measuring some sensitive device, I don't want the power from my computer, some power noise from the grid going to that device. I want to have some onboard control, so I can use the device without the computer host. I can just select which voltage I want to output and that. Some other nice things to have, besides this main output, which can measure current and output some voltage, why not add another smaller auxiliary power supply, which will go just to 0 to 5 volts to power some, if I need some other microcontroller to be powered from different voltage, yeah, why not? And I want to have digital inputs and outputs, because when I'm profiling the current consumption, I want to know, I see that at some point the device pulled a bit of more current, but I want somehow to correlate that with the code. So with these digital inputs, I can connect them to the serial output of the device, so I can correlate the power consumption with something I wrote on either I toggled the pin or I wrote something on the serial output, so I know which power peak means what. So those are some nice things to have with this device. So. And how would it look? Something like that. Should be a portable small device. We have 3 terminals, like main output, or if we can use it as a pass-through device. There are some connectors, GPIOs here. We have a display and the encoder to select basic functionality. I haven't still decided if I want it to be like horizontal device or a vertical device, so yeah, I need to decide on that, but we're still far from that point, so I have the time. So, with project like this, with any hardware project in general, what's the process of designing a new hardware device? Well, you start with specification. Specification is similar to what I just said, what I just listed, a list of features which I want to have, but in a bit more details, limitation, specification, what I need, what's nice to have, and similar. After that, we go to the schematic. Schematic is just a step where I select each component, each electronic components, and define electric connections between them. After that, we go to the step of routing the PCBs. Then there's PCB manufacture, assembling the PCB, which can be usually done at the same time at some manufacturing fab house. And then we write some firmware for it and do some testing. After that, we're done with that revision. We go back to the schematic, fix some stuff we messed up, because even simple things in the first revision usually have some small mistake, but in the complex project, you usually have at least 2 or 3 revisions like this circles. And that's it. With this Jellyfish OPP project, I'm currently here. I have full schematic defined, and I'm in the PCB routing oh, sorry, 10 minutes. My plan was to have the finished PCB by the DORS CLUC, but other things like this got in, so it's a bit delayed. So let's go to the functionality. I'm constantly mentioning how we want to measure current precisely, blah, blah, but how to actually measure current. Here we have Ohm's law, the basic law in electronics, which tells U voltage is current times resistance. So in electronics, it's really easy to measure some voltage. Basically, we have a thing called analog digital converter. You put it across something you want to measure, and then you read it with the microcontroller, and you get a digital representation of value of some voltage. So if we want to measure current, its easiest way is to convert it to measuring voltage. How to do that? We have DUT device under test, which we want to measure its current consumption. We just put a resistor in line with it, and then measure the voltage across it. And that's basically, we know the value of this resistance, we know the value of this voltage because we measured it, and we divide the voltage with the resistance, and we get the current. And that's what we do. But there's a problem with this approach, because since whenever the current is flowing through some resistor, there is some voltage on it, which means this device doesn't get the full voltage from the power supply, because one part of it stays here, and it's based on the current. So if we have, to simplify, 1 ohm resistor, and the current is 1 amp, then the voltage across this resistor is 1 volt. So if we're powering the device with 5 volts, and 1 volt is here, then the device only gets 4 volts, which is not good. If the device is made for 5 volts, if it gets 4 volts, that's not good. It will not function properly. So what do? We can put the really low resistance value, like put 0.001 ohm, which is fine. But when we go that low, then there's a lot of noise. We need to amplify that value to get some usable value. If we amplify it, then we also amplify noise, and it sucks. So what do we want to do? We want to do, like on the multimeter, we want to be able to switch the measurement ranges. So we put multiple resistors, and depending on the current, we switch which one we use. And that's it. So we have a really small resistor for high currents, a bigger one for the medium currents, and that. That way we always can select range to in a way that as low as possible voltage drop is to optimize the voltage drop on the resistor to be as low as possible. So now when we know that, let's start with this. So I started doing, this is my tweet from like when? April. What started as just slightly improved Nordic PPK2, the device I mentioned before. Turned out after drawing the schematic, after putting each of these features I mentioned, I ended up with 22 pages of the schematic with a bunch of components, bunch of everything. So let's see why. What's the architecture of the device? So we have a flexible power input from the USB power delivery. That goes, we need the different smaller power supplies to power every part of the device. We need some way to switch those resistors for current measurements are usually called shunts. So we need a way to switch between those measurement resistors. We need a way to measure that voltage on the resistor. We are using the analog to digital converters. Because we are using it at a higher rate, quite high rate, and we have a microcontroller doing the communication, we added one FPGA chip to handle the sampling, and then it can just, when it samples the value, it can just give the numbers back to the MCU. MCU microcontroller will handle the USB communication with the FPGA and the user interface and all the other things. For actual power output, we have a switching pre-regulator, because switching regulators are much more efficient, but they have a switching noise at the output, so it's not really good for powering some sensitive devices which require a really clean power supply. We have a switching pre-regulator which sets the voltage to a bit higher than needed, followed by a linear output stage. A linear output stage will give us clean power output, but it's not efficient and it heats up, and it's better when the difference between input and output is as low as possible. So we are using the switching pre-regulator to minimize that difference between input and output. So how it looks, this is like a block diagram of the whole device in the schematic. So we have a block with the power and data connectors, USBs for the power input. Going to the power supplies, here's the main microcontroller. It communicates over this link with the FPGA, which communicates with the analog to digital converters here. Here's the current measuring part. We have the output control here, and we will go to 3 minutes. I don't have time. So basically, this is the power input. We have 2 USB-C connectors and one regular connector. This one is used both for powering it and for data communication, but we can use the other one for powering it from the phone charger, for example, and this one just for the communication, if you're using phone which cannot provide enough power. A relay for galvanic isolations with some isolators, and the current the shunt switching, which I said, we need to have multiple measurement ranges. So this is it. Like we have initial 0.1 ohm resistor. It's the lowest range for the highest current. Then we have next one is 0.1 range, which should measure up to 300 milliamps. Then the higher one, 1 ohm, which is used for measuring up to 30 milliamps. This one used for up to 3 milliamps, and this one used up to 300 microamps, and this one used for up to 30 microamps. So, and we have some logic here, some switching to be able to switch between those. And that FPGA, which is controlling the analog to digital converters, is also responsible for switching between these based on the current. If it sees the current rising, it will switch to lower range. If it sees the current falling, it will switch to higher range. And it can do that pretty fast, usually under 1 microsecond, which is enough for this case. This is current sensing. I will skip over this because I don't have time. FPGAs are a bit complicated because they need a lot of different power supplies. So this is the FPGA part. The output stage, So in the end, after I drew complete schematic, I found some possible issues. The issue is that in those 22 pages of the schematic, I have over 760 components on the board, which is quite a lot for boards that should be this big. And a bigger problem, that's not a big problem, bigger problem is that around 120 different components, which means when you're assembling it by machine, the machine needs to have a lot of input feeders. Or if they are switching them, it becomes really expensive. So it's not really affordable. Because we have those ADCs which can sample that fast are like 20 euros per piece. We have 2 of them, and it quickly adds up. But after I finished with this first revision and I tested, I have some ideas in mind which should lower that total cost to do, because not everyone needs that 2 ADCs each sampling at 3 megasamples per second, because one can be used to multiplex both current and voltage at a lower rate. So that's one optimization. We can go without the FPGA and ADC with a lower speed ADC. So yeah, to further for some users which don't need it. So that part with sampling should be a module which can be replaced. And also the whole power input with 2 USBs and DC input can be another module which can be like few different modules if someone needs just the DC input or just the USB, so just select that module. So that's my next step. I hope to finish the PCB in the next month or so, and to have the first revision of the device probably around September, like that. So if you have any questions, ask, or I will be here for the rest of the day, so you can find me. This is my contact info, my Twitter, YouTube handle, website, and thank you very much. So, any questions, or we can do that later? Thank you.
Hello, the next lecturer is Andrea Okinawa. She'll be talking about building type-safe serverless.
Hi everyone, thank you very much. It feels so great to be supported by my friends that are also from Romania. So I'm Andrea, I'm from Romania, and I'm a teaching assistant, and I'm also a software developer interested more in cloud and web development. So first of all, I feel like in a lecture because everyone just transitioned to the back of the class somehow throughout the day, but that's okay. First of all, I want to kind of know you. Are any folks there here into cloud or web development? Okay, great, great. For everyone else, I'm just going to give context for every concept that I'm adding into the presentation. So I'm actually working at a startup, and we managed to build a cloud platform that is running serverless. I will explain what that means in a moment. But for the effect, what we are actually doing is that we are managing to, can I close this slide? Like this. Okay, great. Don't fall asleep. Yeah, so we've actually managed to take this kind of front-end code and just simplify to this version. So basically what we're actually doing is that we are abstracting away more code complexity, and we also do type safety on the front-end code between the back-end and the front-end. So we gave the developers a way to actually know what types and what methods are on the backend side into the front end. And we are going to see how just in a moment. So first of all, I told you that we are leveraging function as a service or serverless, and let's see what that means. So FAS, or function as a service, is a lightweight server that is going to be launched for a limited period of time. That means that when an incoming request is coming to my cloud app, a server is going to be spawned, a lightweight server. So we want it to be fast, and also we want it to be lightweight in order to not get bloated and have more RAM or more CPU allocated. So as our application is going to be more used, we are going to have more incoming requests in such a way that we are going to spawn multiple servers for each request. After the request is handled and the response is coming back to the user, the server is going to be shut down. So essentially, we can actually scale down to 0. That means that we are going to have the following advantages. It's going to be cost efficient because we are not paying when we are not actually using the server. So if the app does not have requests or users, it scales down to 0, and we are not paying for that time. Also, much more than that, Genesio, the startup I'm working for, also has configurable hard billing times. So actually, the problem in industry right now is that we are misconfiguring something in Google or AWS, and we end up with an increased bill usage overnight. There are many kind of these incidents in the news. So the problem is that if we are misconfiguring something, we are going to end up paying for our mistakes. But we are able to actually put a hard limit on the billing usage, so in order to protect you from getting overbilled. So it's cost efficient, and it's auto-scaling. As incoming requests are coming into the server, we are going to spawn more and more VMs to host that spike. And also, it has reduced development complexity because we can write much less code also on the back end and on the front end. We don't have to maintain as much code. We don't have to test it. We don't have to find bugs into it. So how we are doing that? Instead of using REST, which is kind of the de facto technology right now for the web apps, we are actually using RPC. And this is because REST means that we have to expose an endpoint on the backend side, and we have to actually code that part of the controller on the backend side, and then we have to talk with the front-end team or with the front-end with the front-end engineer. We actually have to tell them what's the endpoint, what kind of types I'm going to receive on that endpoint, and then the front-end team can actually start to implement that. So it's the REST way has more steps and has more code involved into it, both on the backend and on the front-end side. So we are actually leveraging RPC, which means remote procedure calling functions. That means that we can call a function as if it's in our own code and our own machine. So we are actually going to call it as one bundle. We are going to see in a moment how, because I'm going to also show you the code. So as I said, it's less code on the backend and on the front end. So we can actually see on the slide the backend. This is a very simple class that is essentially my microservice, the backend service. And we also have a hello method that receives a person, that is a type, and does something with the person, print it on the console, and that's all, it returns. So on the front end side, what I actually can do with RPC is that I'm just, instead of doing a GET request with Axios or with fetch or something else, I can actually just call the method as if it's implemented right here, right? I have backend service hello and the person thing. This is not happening right now in web dev, so we can't do this with Express or with the conventional tools and frameworks that are right now in web dev. This can happen only with Genesio. So how we are doing this? We are actually kind of reading through your backend. We are reading to your backend. We can parse the methods, the types, the parameters, and the return types, and we are kind of creating an intermediate representation for that types. Basically, we are kind of half compiling the code that is TypeScript into an abstract syntax tree in such a way that we can then generate an SDK. And the SDK can be imported into the front-end part, and it can be used. So putting it all together before the demo, just in order to understand what we are going to see, what you can host on Genesio is basically your front end that is going to have the SDK embedded into it. You are going to call your backend with Genesio RPC, your backend, and all of this is hosted on our platform that is a function as a service platform. So now we can actually go into the demo part of it. Let me just, can you hear me right without the microphone? Because I have to use my two hands. Okay, great. So I have here a simple task service, which is a microservice that is basically getting tasks from a database and adding a task to a database. So I can actually look into it, and what this method does is just it takes a token and a title, and then it adds this task to MongoDB, and that's all. So how I would normally call this function in a REST way is that I would have to have here an endpoint that will accept GET on whatever my API URL /tasks/task, right? So this would be on a REST API doing stuff. I would have to actually implement the controller for this thing that will then later, anyway, this is going to be a put, but doesn't matter. So I would have to implement the controller on the backend side that will actually call the end task. But right now I don't have to do this because I can actually call Genesio local, which is going to look into my code. It is going to detect that I have a task, that it's receiving 2 strings, and is going to return a promise that is a get response task, which contains a Boolean, the task, and error if it's an error thing. So let's actually look into the front-end part. So here I would have, this is the front-end part where I'm actually calling the add task. So here if I would have REST, I would have to do an Axios that would do a get, yada yada on the endpoint, that will do a put, sorry, with on that endpoint. But what I can actually see is that I have task service here, which is imported from the Genesio SDK for this demo. So I specifically got a generated SDK for my backend that's exporting task service, which is the microservice, and also task, which is the type of the task that I'm returning. So let's get back to add task. If I'm actually doing this, I can also see that the IDE is going to autocomplete this for me. If I'm hovering this, I'm getting the types, the parameter types, I'm getting the return type automatically. So I did nothing for this to happen. So I also get the documentation and all sorts of that stuff. So in order to see that this is actually true, let's actually modify this parameter to be a request. I'm going to create a new type, add task request. And instead of using title and token, I'm going to use this request throughout all my function here in the backend. And I also have to create this type that I've newly created. I'm going to export it here. It's also going to contain a token, which is a string, a title, which is a string. Great. So as you can see, the backend is, once I save the backend, this Genesio local that is going to keep generating my SDK is refreshed. And now I can also see that I have an error on the front-end side. So this error is because the IDE is telling me that this is no longer the footprint of the function. If I'm hovering over it, I can see that it got refreshed. I have request, add task request here, and I have to also change the front end in order to match the backend request. So I can do this, and this is going to maintain a type-safe communication between the front end and my backend all of the time. So I cannot put anything else here. So if I'm trying to put a string here by mistake, let's say I want to just put the task title, whatever, you can see that this is an error. And in the REST word, this doesn't happen. In the REST word, this is going to be a bug report found by QA or by the front-end guy, which says that this cannot happen, right? But this means that some people investigated and some people lose some time doing this kind of investigation of what type should be here. Let's go here. Okay. So in extension to this, we can also, everything that happened here is locally on my device. But as I actually told you, we also have the function as a service platform. So after after I'm done writing the code, I can actually deploy. So we can just go and hit Genesio deploy. And this will bundle the backend code and the front-end code. They are going to be bundled together, and they are going to be hosted on the function as a service platform. And once that hits a request, it's going to spawn VMs that are going to handle those requests, and then they are going to shut down. We can actually do that because instead of using Linux and VMs or containers, we are actually leveraging something that is called unikernels, which are specialized kernel containers. Let's say Rizvan and Stefan just had some talks about that yesterday, if you've been there. And we can actually see and test that this actually happened, the deployment. Yes. So this is actually the front end of what I've just showed you. And when I'm hitting here a new task, deliver this presentation. And when I'm adding, the machine just spawned, put it into the database and shut it down. And this is quite fast, as you can see. Okay, and we also have this thing. It is hard to test RPC in real life. You would either use Postman, but Postman is very REST biased, as everything in web dev is now. But we are also leveraging a test interface that is a Postman-like tool, where you can actually test just the endpoints of your functions. So we also have get task and add task. And as you can see, you can also see the types here that we have on the backend. So this is also type safe. So it helps you test and you know what you are actually testing. And this is also comes out of the box. So this is not like Swagger where you have to write some things before you actually get the Swagger. This is out of the box things. Anyway, and it works. So basically, if I'm just adding a task here, token to do, I can also get it here. Token. Yeah. So I also had that to do it here. Let me go back to the presentation itself. So this is kind of the end of the presentation. I actually hope that I sparked some interest. And if you have questions right now, I'm more than happy to take them, and maybe you can discuss the code. Yeah.
So actually, I have multiple questions. So the idea here, like for example, yeah, you would have like this, let's say, server which is running on Amazon, and I want to, I don't know, switch over to Genesio. Does that mean that I have to have like my own cluster of computers and just run it locally, or is this product supposed to be used by, I don't know, Amazon to cut costs, or who is actually saving cost here?
So who's saving cost is the full stack developers that are developing web applications. So basically, this is not going to be used by Amazon. It's going to be used by the end user of Amazon that are paying thousands of euros per month to keep servers on Amazon, which is quite expensive on my opinion. So these kind of projects are going to be migrated on Genesio, which is also a hosting platform.
Okay, so basically you have your own cloud, or?
Yes, we actually have our own cloud. So these VMs are actually run on, like, we are actually spawning them. We have an orchestrator that is running on bare metal that we actually buy.
So, okay. So, and the second question is, so basically, if I have my website written in some obscure language, I kind of have to transition to the languages that you are supporting.
So yeah, that's true. So there are two quite long answers here. So first of all, we are working TypeScript and Go on the backend side, and everything else on the frontend side. We are quite frontend agnostic. But you can also implement, because it's an open source project, most of the parts of the project are open source. You can also implement your own support for the backend. So if you are running a obscure thing, you can actually help you to generate the SDK for that obscure programming language that you're using. So you have to get your hands dirty and contribute to something.
So the AST that's being generated in some sort of intermediary language, that's just for the front end or for the back? Because it sounds like for like a lot of work, right? To match ASTs, right? So
the SDK is generated by the Genesio tool. So why do you actually say a lot of work? So
maybe I misunderstood, but like if I want to use one language, I have to kind of pass, I don't know, the address to that function to the Genesio backend, right? And then Genesio needs to kind of understand that code. So if I'm using like Rust, you basically have to generate the Rust AST, and then Genesio needs to understand that. So if I'm understanding correctly, right?
Yeah, that's true. So basically what you have to ASP, the intermediate ASP. This is the technical depth that we are paying at the video. So we are actually implementing that for TypeScript and Go, Python, and something like. But for future programming languages, yes, we have to do that.
Yeah, but that's not easy, right?
Well,
I mean, how long did it take to implement, I don't know, Python?
so we did it in a kind of way that is like 2 or 3 days of engineer work.
Hi, I'm not so much familiar with the Geneseo platform, but I've used AWS. So what I have on AWS, I'm not using it only for Lambda for serverless, but there I have DynamoDB for some state, or let's say CloudWatch to provide some metric, S3 buckets, CloudFraud CDN. Do we have the same functionality in Geneseo, or is it missing, or you have to combine?
Yeah. Okay. So we are providing the corresponding thing for CloudFront for hosting, for front-end hosting. We are giving native Postgres, SQL databases. We are working on NoSQL databases. We don't yet have that, and we'll also have authentication out of the box. So I don't know which is. It's Cognito, I think, in AWS. Yeah, okay. So we have those. We are on our roadmap. We have more of these things that we want to implement in order to that Geneseo is a go-to development platform. So we are actually aiming to that. But in the meantime, you also can bring your own database. So you can bring your own DynamoDB. Geneseo doesn't stop you from doing that.
Any more questions for Andrea?
What's the most benefit of the architecture? Is it portability, the ability for you to write in multiple languages? The main benefit, what do you see of it? Being, yeah, of this, let's say, architecture and the development of an SDK that you can quickly use, the entire process.
Yeah, so I guess there are two things. We actually, because we are actually leveraging our own cloud, we are actually able to reduce costs of keeping up the infrastructure.
No, that I get. I'm wondering about this process of ASD and having having a common SDK for multiple languages. Is portability, making it easy. I mean.
It's making it easy to call, to glue together the front end and the back end. Because right now in the web dev world, these are two separate things. And in order to connect them, you kind of have to put in some work. You either have to bring the back end team and the front end team together, or you also have a full stack team that knows both of them, and they can also they can do both of them.
Okay.
So the SDK thing is basically to bring these two together, and also cost development time because it's easier to develop and much quicker.
Okay, and is there, or do you plan to have some sort of app store of, I'm not sure, backends or front ends that people can reuse, or it's everyone's business to create their own?
So the backend. So we are actually kind of trying to do a kind of a marketplace.
Yeah, the marketplace. Yeah, a marketplace. The marketplace. Yes.
Marketplace of open source projects in a way that if you are developing a Geneseo project, other people can take it and deploy it on their own infrastructure and then contribute to the project more.
Okay, and finally, do you? I mean, maybe part of the backend. Are you able to also use databases, or those are separate services? There would be two unique kernels. How would that go, or is it just for something that doesn't have any sort of persistence?
So right now, the databases are basically the native Postgres that we are providing is basically hosted somewhere else.
I see. Okay.
White label for that. We are not really hosting the databases themselves.
So databases are a different service that you don't care about. You can connect to it, but it's somewhere else placed. Okay, gotcha.
Hello, thank you for the presentation. I have a question. For a mature project that has been long in the market, what are the benefits of migrating to Genesio? Because for a major project that works almost every time, I didn't see the benefits yet. Yeah, I already have a project on AWS, and the project is quite mature, and it has uptime very big. And what are the benefits of migrating it to Genesio? And the second question, do you have some dashboards for monitoring or observing stuff like metrics or so? Thank you.
Thank you, Andrea.
Oh, and also I have stickers. If someone wants them.
let's welcome Neven Pirushki. He will talk about using bash to bash Windows.
Hello. Thank you for gathering here in this large number. And hello to everyone watching this over the internet. If the slides are not as visible as desired, under the video frame could be the presentation slides for you to download. For the beginning, who am I? Well, my name is Neven Pirushki, and I've been into IT for quite a long time. And I've been breaking stuff basically since the primary school. Currently, I'm at the company in Figo, and I'm doing some penetration testing, in fact, a lot of penetration testing and red teaming, which basically means I go around and break the computers of our customers. The obligatory slide about the company, we got several departments. The coolest department is cybersecurity. That's where we hackers are. The other departments are not so cool. We're the coolest ones. We got the solutions delivery department, which basically helps our customers implement some defense thingies that makes my job a lot harder. We've got the consulting people, which do a lot of meetings and Word documents and emails. We got the software solutions people. They develop some custom thingies, which are not that much of our concern, of my concern, like my departments. And we got managed services department. They're the worst because they monitor the security of our customers and help them catch people like me. Even worse, when real bad guys do some damage, they do some incident response and help people recover. So all in all company is great, a lot of young people, and we help each other a lot. So since I had to prepare this presentation at the last moment, I asked one of my younger colleagues to make a short agenda, and I'm pretty certain that I can rely upon my colleagues, even the younger ones. So as expected from an older guy, I'm going to talk a lot about the history of IT and of some open source tools and security, and do some helpful conclusions at the end. So let's start from the beginning. Computers are complicated. And a long time ago, when I started roaming around the internet was way cooler. So we did not have to bother with all the modern colors and mice and all that stuff. If you needed to do something on some system, many of them had no password and many administrative interfaces were open, so users can freely help themselves without bothering some administrator who might be drinking beer and be really busy to help his users. This is one of the first machines I used to access the internet in the 90s, here in Croatia, in Zagreb. This was actually a premium one, because this is the advanced model. So soon after that, Microsoft Windows was becoming really popular. Also, the open source and free software was becoming more and more popular, but Microsoft Windows got way more attention and brought many more people to the internet, people who were not quite advanced users or gurus. So to accommodate for them, some new procedures were implemented, like the systems were not so open anymore, and we had to use passwords, and it was really inconvenient. If you wanted to log in and you forgot your password, or you wanted to log in as your colleague and didn't know his password, you had to enter his password. So Windows 95 had a convenient convoluted feature that if you did not know the password, you had to click on the help button. Then some help pop-up thingy goes up. Then you had to go to the print and press a lot of those buttons and use those pesky mice. and do a bit more clicking until you finally manage to get where you want to be, which will be shown in a second. So yes, desktop, my computer. We're still at the login screen, and we still do not know the password. But at this moment, something crashed, and you get the desktop. This really worked. Okay? So it's convoluted. Who would want to go through that many steps just to log in as your colleague? It's complicated. So other operating systems which aim to be more usable had their attempt at feature that users could obtain administrative privileges as shown on the screen. And unfortunately, it worked also from the remote over the internet, but unfortunately they removed that feature soon after it was implemented. Basically, it was a root user without password, automatically activated by some services. So we had to use passwords, and we tried to fight back. Passwords such as the one in the first bullet are complicated, and us a bit older people had a hard time remembering them. And they even made some hashes, which is basically they take the password and convert it into some obscure form, which they then store on computer. So you cannot help your colleague by reading his password.txt and figuring out his password, because it's scrambled as this hash. So what can we do about those hashes? Now free and open source tools come into play, and one of them, which I'll show here, is called Hashcat. So if you take someone's hash, let's say it's using the anti-hash algorithm, which is quite popular nowadays in Windows environments, and you put it into this tool, as shown on the screen, this tool will do something like 8 billion attempts at guessing the password each second. 8 billion times each second. This is not a big cracking rig. This is my laptop I'm holding this presentation on. So this is a single laptop, 8 billion times per second. This is way better. So you get someone's hash, and you have a way to relatively quickly figure out which password it corresponds to. But let's say you're really in a hurry, and you really need your password. Well, you could basically aim for a bit older algorithm for passwords, which is called the LAN manager algorithm. I really like it because it forces you not to have passwords more than 14 characters in length. It does not mind uppercase or lowercase letters. It really doesn't mind. Uppercase, lowercase, it's all the same to them. And the best part is when it makes a hash out of the password. It doesn't make a hash out of the whole password, but it splits it in two. So it reduces the number of attempts from 2 to the 45th to from 2 to the 86th. Okay? So basically, what does that mean? You put that into any computer with a relatively modern GPU, and you can figure out the password guaranteed, like all the combinations, in, let's say, half an hour. Okay, so I really like these ones, but okay, I'm talking about some hashes. Where can you find the hashes? You have many options. So modern Windows-based computers tend not only to cache the hashes, but not only of the user that's locally using it, but also from other network users that interacted with that computer, including the administrators. Grabbing those cached credentials these days can be a bit difficult. It requires you have some control over that computer, but we do not like difficult and complicated. We want to make it easy. So you can contact that computer over the network and ask it, could you please give me all the credentials? So there are several ways of doing that. One of the ways that I'm going to talk about relies upon the protocols used for resolving the addresses. So real old men use IP addresses and not some fancy names like www. something. But nowadays, the fancy names are really popular. So to translate from one to the other, a service called DNS is used. But it's also kind of complicated because you have to configure it. You have to write down the whole IP address of the DNS server in your computer. And nowadays people do not even want to do that. So they invented another group of protocols that's basically broadcast resolving. How do they work? Well, basically, it's something like if I ask all of you, hey, does anyone know at what address my bank is? And whoever gives me an address as an answer, I go there and I give all of my credentials there. Okay? This is something that modern operating systems by default use, both open and closed sourced ones. So how can we make our life easier by addressing this issue? Well, let's first see how is this used? Well, basically, as I said, the victim asks a question, and the attacker does not send him the wrong way. It says, oh, I'm that server. What do you need? You needed mail server. I'm your mail server. And the computer automatically tries to log into the mail server. To make things even more interesting, modern computers, you remember those cached passwords, they try them all. Like, okay, hey, hello, mail server. Here are my credentials. Oh, you do not like them. Oh, wait, I got more credentials. And it basically tends to give more and more credentials to the attacker. Well, I like that, and those credentials are usually hashes. So I prefer to call this method password backup as a service, because basically you start a service that answers to all of the broadcast resolving queries with, it's me, send all your credentials here, please, yes, come here. It's called Responder. It's also free and open source, way better than closed source ones. It helps you back up your passwords and the passwords of your colleagues. So if one of your colleagues forgets his password, you can help him, maybe by cracking it or not. But the various algorithms for making hashes are, some of them are easier to crack, some of them are way more difficult to crack. So I prefer the easier ones. I want to make my life not difficult, but more pleasant. But modern operating systems tend to prefer those complicated ones. And the responder has one option, which basically says to the computer putting the query, my responder says, hey, I'm an old computer. I do not understand all these modern algorithms. Could you please downgrade your algorithm to something that older computers can understand? And ESS is one of those shown here, but the LM is also one of the options. And that's really convenient, because then I can get your hash with a really simple algorithm. So if you want to know your password, I can crack it really quickly. Okay, as I said, in our company, we all help each other. And our younger colleagues have great respect towards our older and more experienced people, often ask for our help and are really grateful for it. So since the summer is coming, cracking passwords generates heat, which is bad for the environment and makes people hot. So the issue is there another free and open source tool we can use to avoid the cracking part, but to use the hashes to authenticate as our friend, because he asked us to? Well, yes, but firstly, I'm going to show you another way how to obtain the password hashes. This tool is called Mimikatz. It's also free and open source. It's made to work on Windows computers. It has really many uses. This is just one of the options it offers. So it offers, if you've got local administrative privileges, to dump some of the cached credentials, which is really great. So you basically run it, and when you get its prompt, you just say something logon passwords, and it pulls out all the cached passwords and displays them to you. Sometimes you do get a real password, plain text password, but oftentimes you just get hashes, okay? And you can, what you want to get with it is something called the anti-hash. Why? Because it's still supported on modern operating systems. And the cool thing is, you do not need to know the password for many things in today's environments and networks. All you need to know is the anti-hash, which you conveniently grab from a friendly computer. So another tool I'm going to show you comes from the Impacket family of tools. Impacket framework is really great collection of tools which enables you to do many things the way they're supposed to be done, from the command line without too many colors and keeping the security simple, as it should be, not complicated. So one of the tools from the Impacket suite is called PSExec, which is cool because if you know the hash of some user, you can use the PSExec tool to execute commands on some computer as that user. And it's really convenient. You can help your friends. You can, if your administrator goes on a vacation, you can do his job and help him relax on the vacation so people do not call him and ask him to do stuff. And it really works. It works on today's computers. This is what we use almost daily. There are several variants of this, but this is the simplest one. As you can see on the slide, you basically get your command prompt as the administrator if the hash belongs to the administrator. But trust me, keep it simple. Grab the administrator's hash so you can do everything. Using multiple users is complicated. You get the administrator and you continue doing whatever you want to do. That's how it should be. Then they said, okay, we're going to complicate things even more. As if the passwords and hashes weren't too much, they invented something they called certificates. And the whole thing became even more complicated. But I'm going to show you some tools which you can use, which are free and open source, which you can use to make your life easier, as it should be, when using the certificates. So, to accommodate for the desire to use those certificates, they invented something, Microsoft invented something they called ADCS, like Active Directory Certificate Services. So that's some service server something thingy. They put it there in their Windows environments and domains to do the whole certificate stuff, okay? And it's really annoying and horrible. Let me show you how it looks. So they got some modern web interface. People should interact with using those mouse and using colored screens and stuff. This is the real ADCS. Maybe it is a bit older, but that's it. It's not as old as I am. So you see, this is awkward interface. You have to use those graphical browsers and stuff. So it does not have an option even to share credentials. Like you want to help your friend with his credentials, it doesn't allow you to. It says you can only use yours. Sometimes you cannot even export your own credentials to give to a friend because they complicate with those things called smart cards and stuff. And it's really horrible. You agree? Yeah. So this needs to be dealt with using the free and open source tools. So what can we do? There's a tool called Certify. Beware, there's a Windows variant called Certify. But this is Certify, which runs on nice operating systems. It's Python, like Python. So it's meant to interact with ADCS stuff. So it has, as shown on the screen, I hope all the people online can see it. There are many actions that can be performed, like authenticating or finding everything the ADCS has to offer to its users. So you come to a restaurant and say, hi, hello, what can you offer me today? The find does exactly that. It contacts the ADCS and says, hi, what do you have there and what can I choose and what can I use? It even points out some convenient features, which we'll see a bit later, which can make your life a lot easier while using the ADCS. So the first one I'm going to point out is called the ESC1. That's basically a feature. So what's the problem? All those administrators and security people force us to obey by their rules. They give us our usernames and say, you have to use that username. They give us some rules and says, you can use this and you cannot use that. That's annoying. That makes people not be able to do their jobs. So you can't even declare yourself as something like a nickname. It's not allowed. You have to use that username and that's it. Fortunately, certificates have one field which actually enables you to put in a nickname in it. It's called subject alternate name, okay? So I declare myself an administrator. And if I find some certificate template on ADCS server which allows me to declare my own nickname, I will say I'm an administrator. And it will give me a certificate which says my real name enforced on me, and it says the nickname I chose, and I'm the administrator. Okay? Then when I get my certificate and appropriate private key, I can use it to authenticate wherever I want with my nickname. Okay? This really works. It's really this simple. Okay? The next nice feature I want to show you is called ESC3. Well, imagine a situation if your friend who works as an administrator wants you to help him and retrieve his certificate because he's busy. He doesn't have enough time to go fetch his own certificate. Well, basically, first you find a certificate template which has something called a certificate request agent EKU, and you grab your own certificate by that template, okay? You've got your own certificate out of some templates that are available to you. You cunningly choose the right one, of course, okay? Then you authenticate as yourself again, but with that special certificate which enables you to authenticate as another user, your friend administrator. You do not even have to call him and ask him for permission because you do not want to bother him. You know your friend will not mind if you just borrow his certificate for a moment, okay? You might think these things are something for a lab environment and for learning. These are really often seen in production environments. I'm not quite sure why. It seems the ADCS enables the administrators to easily make mistakes and enable such certificate templates. What I do know is we see them all over. Okay? The last ESC is a really fun one. Well, it's basically that web interface I showed you earlier. It's a bit complicated, so I'm gonna try to give you the TLDR. Basically, having that web service, that web page, web interface, web thingy we saw earlier, enables me to relay or forward someone's authentication. It basically goes something like, I point out some machine on the network and say, hey, could you please authenticate to me with using some of the tricks? When it authenticates to me, I relay that authentication to the ADCS server in order to retrieve the result, retrieve the certificate of that user or machine, okay? It can be hardened, but by default, it's not. And the last thing about certificates you should be concerned about is what if your friend administrator makes a grave mistake? It changes the configuration of in the environment, so the features I showed you before no longer work. That would be terrible. We'd have to go through all of those procedures and call people and ask them if you are allowed to do something. It's really terrible. So in order to avoid that, and people can make mistakes, your friend administrator could lock you out, you can, well, basically proclaim yourself either the permanent administrator or even better, a CA server. So you got your own server which makes certificates and it's under your control. That's one of the great features. You basically future-proof yourself. So we're really running out of time. What's next? Well, basically, this is unfortunately only a short lecture. So I do have more open source tools to show you which can make your life easier. You can enable yourself to more easily access other people's, I mean, your colleagues, your friends' files. You could do similar thing to the email. You could bypass that pesky second factor authentication thingies. Who wants to do that? It's complicated. You could do a lot more stuff. But since we only have few minutes left, I'd like to ask you if anyone has any questions. Well, the selection was basically for Windows, but macOS, last time I checked, by default used the MDNS, that's the broadcast DNS, which then in turn enables you to do many other fun stuff. And if macOS tries to use Microsoft algorithms for authentication, the same thing goes for them. No. Responder covers MDNS. Last time I checked, Macs by default use MDNS. You also use MDNS. Well, Certify is meant to work with ADCS, and the Macs do not have ADCS. But if you integrate Macs into the Windows domain, which uses ADCS, they're not vulnerable, but the whole environment is vulnerable, and they're the part of it. I got it. So the part with subject alternate name, it's a feature and it's the configuration of a specific certificate template. Okay? There's some reason which I do not understand, and frankly I do not quite care that much about, why the administrators that often make certificate templates which enable that field. I do not know why, but I do not, it's common. And it's considered a feature is the configuration, it's the misconfiguration of a certificate template. I really do not know if it's default. What I know is we see it all around. It's really popular for some reason. Yes? The default wireless behavior of Windows laptops is a topic that could deserve another lecture like this. It has interesting features, and we can talk about it a bit later on if you want to. Yes? Most definitely, some parts of this are for backwards compatibility. The older algorithms the older hashing algorithms are strictly for backwards compatibility. And for known reasons, they are reluctant to remove them, but they're really bad and security issue. So yes, there's quite a bit of backwards compatibility behind these. More questions? Thank you very much. You've been a great audience.
Mike! Thank you all so very much for contributing, for being here. We hope you had a really good time. Hope you met some new friends, people, made new experiences. And before we go on with the closing, I would please ask you to give a big round of applause for all the organizers that were not visible, like a couple of us are. Thank you. Every one of them has been volunteering, so thank you, each and every one. Also, we will not be here without the support of Algebra University, so again, it's important to mention this, stream it, and record it. We appreciate it very much, and thank you very much. of course, our sponsors also played a big role in making all the little arrangements possible, all the logistics, materials, food. Thank you to them as well. And next up, we have a couple of prize games that I'll let Andre tell you about what happened. Thank you.
So for the Smart Account prize game, I'm not sure this is going to translate. I don't know, whatever. So for the Smart Account prize game, the winner of the 6 months of free accounting is Christian Solo. So if you're here, congratulations. Let's stop here. Then for the most amazing prize, every year we have this, and it's getting very, very nice, and people are actually expecting it. As well, I made it complicated on purpose. I hope you can read the handwriting later. Let's see. Anja Pureber won the. Next job with the heart. Thank you.
So the formal part of the conference is over, and tomorrow and the day after we'll continue with the Unicraft Hackathon. So if you haven't registered yet, you don't have to. You can just show up tomorrow morning at 9 a.m. here at the B1 and B2. There will be, I think, around 10-15 people.
And there will be pizza and everything, so...
Yeah, pizza and everything. I'm pretty sure it will be fun, so feel free.
Yeah, do join, do join.
Yeah. And of course, after the closing ceremony today, we're going to go to the Treasure Cafe for the conference party. I hope you all have the coupons for the drinks. If you don't have, let us know, we'll give you some. And that's about it. I just want to ask you one more thing, is to go with us at the front of the building, and we're going to take a group picture of all the attendees like we do every year.
We're not done yet. Just a second. Thank you to our wonderful speakers this year. We couldn't have done it without you, to our keynote speakers. Please apply. We're already starting for the next year, Monday. We're also looking for sponsors. Again, please come talk to us. We're trying to scale this up to make it something more beautiful for the 30th jubilee. I don't know how to read that word. So yes, come talk to us, contact us. We already made some plans with OpenIP.
And if you have any suggestions, for the 30th conference next year, let us know.
Okay, let's go take the photo.
Yay!
items and so they get spend some time doing it. I mean, they're only doing it for but see a lot of people there we can figure out. They're going to the city. How are you? How's it going? I think you're not part of some sort of holding with different sub companies. I see, yeah. I met with him and money that they opened for business items. So are you still working with the embedded world or stuff or? Yeah, we'll see how it goes. I mean, it seems like a good thing. A lot of people are excited. There's a lot of people are excited about technology. We still didn't reach kind of, let's say, a sweet spot of what clients users want, but we are tackling all of it. It's a bit of a chicken and egg because if you don't want to do something, but you also want to test, there's some sort of market for that, and people want that to happen, but if not that, maybe then it's not that what they want, so it's kind of a continuous process. But it's yeah. I mean, you have that ability to test the technology, and Cloud is the product itself. And we're going to see how that goes. Yeah, thank you. And we'll keep in touch. We're going to keep with I mean, I'm not sure, guys. If you want to catch up, if you have some time during the week, during the evening, we can do that. You're in that wine town, if I recall. Okay, yeah. So is it in the south? Yeah, it's on the. Okay, I see. Between I see. Okay. Okay, well, I'm going to say, so I mean, and how long does it take to get here? 2 hours? Around 4. So I mean, when did you get here? It was a few days ago. So you have a place here and you then move back. I see. Yeah, sure. So you're not getting back this evening? Well, not this evening, but I'll have to check what else I have. I mean, how much time do you spend in Zagreb per month? Half of it? Depends on the month. Right now, I think it's quite long. Right. I see. Yeah. Thank you. Keep in touch. And best of luck. Alex Jung. Yeah. He's not here. I mean, he's in Germany. No. I mean, this was only the bunch from Romania. I mean, it's me from the company. There are 2 other people from the community and 6 others that we attached with different technologies ideas. As mostly students and collaborators and that kind of stuff. But it was lovely being here, and we're going to be here the next year and so on. The plan is to organize something similar to this in Romania in autumn, so that we can have some sort of pairing at Croatia in the spring in autumn, and then to speak with Svebor about. He has an idea of some sort of let's say Eastern European Gulf of life was them. So think about that. I mean, there are things that are saying, but we'll see how this is going to take it easy. Yeah, by the way, I was thinking of maybe visiting Romania. If that is the case, yeah, to let me know. Yeah, I mean, we can catch up one, then but I can make also recommendations. It would be to there. Just get how it goes. Maybe you can chat on LinkedIn to give me the Shimeni. How do you SCH? What is it? It's S with the Simenek with the K at the end. I recall. Okay, keep in touch. Yeah, thank you. Dacă vin și o 2 minute.
Ajmo ti par dana.
Nisam točno znao na hostingu i svemu. Baš mi je drago da je dalo i super mi je za sljedeću godinu već zanimljivo i baš je Andrej rekao bio baš preći neki a tamo može da uči ekipe iz Marsa. Dosta malo. Ti najbolje kako radi, ti još najbolje kako radi.
Pa da, sad kad te pite, reci, bilo je užasno, stalo sam već morao.
Preko vremeni, stari moj do 11 navečer.
Ah, yeah, yeah. You will be here?
We'll come over.